Welcome to this 2-hour preview of the complete Node.js developer class. I'm Andrew Mead, and the goal here is to give you a preview of the class before you choose to enroll. What you're about to watch is literally the first 2 hours of the class exactly as it appears on Udemy. In the description down below, you can find a link to the course landing page. There you can check out the full curriculum and explore all of the fun and interesting projects we'll end up building along the way. All right, let's go ahead and jump right in to the class preview. Welcome to the class. I'm Andrew, and I'm excited to show you everything that Node.js can do. When I first started teaching Node on Udemy about 5 years ago, Node was a super popular choice, and that has not changed. Over the last 5 years, a ton of great new features have been added to Node. It's only gotten more popular and more mature as a tool, being used by professional developers everywhere. Now, in this course, we're going to cover everything you need to become a professional Node developer, but in this video specifically, there are 3 important things I want to talk about. First up, we're going to talk about the curriculum. We'll talk about how we're going to go from where we are now to where we want to be, which is a professional Node.js developer. The second thing we're going to talk about is how you can get the most out of the class, and finally, we'll talk about how you can get help if you get stuck or if you just have a question about something covered in the course. So let's go ahead and jump right in and talk about the course curriculum. The curriculum for this class is broken into 4 major parts, and in each part, you end up building a brand new application. By the end of the class, you'll have built a Notes app, that's part 1, a Weather app for part 2, a Task Manager app for part 3, and finally, we'll be wrapping up the course with a chat application for part 4. Now, with every new feature you learn, you're actually going to integrate it into an application. So the goal is not just to learn features in isolation, the goal is to figure out how to combine these features together to build useful and interesting apps. My goal for you is that by the end of the class, you can build useful and interesting apps on your own. At the end of the class, I'll actually offer up some suggestions of what you could build based off of what you learned. Now, the first app we're going to build together is the Notes application. This is going to allow us to explore the very fundamentals of Node. So you'll learn how to create a Node application, you'll learn how to load in the various features that Node provides, and you'll learn how to run your apps. Along the way, we'll explore some interesting things that Node can do, such as reading and writing from the file system. Now, once we have the basics down, we're going to move on to the Weather application, which is a web app. So the user will interact with that app via the browser. This application is going to require you to learn about creating your own Node.js servers, building your own API, and communicating with third-party services, such as a service that allows you to fetch real-time weather data for a given location. The app after that, the Task Manager app, comes with all of the features you would expect from an application. This includes authentication with an email and password. It includes real database storage in MongoDB. We're also going to cover useful features like file upload, email sending, and more. Now, the last application you'll be building is a real-time chat app. So you're going to learn how to use Socket.io and WebSockets to create real-time applications for you and your users. Now that you know what you're getting yourself into, what I want to do is offer up a couple of suggestions as to how you can get the most out of the class. This course was designed to be completely interactive, so to get the most value out of the class, you need to interact with it. Everything I do on my machine is something that you should be doing on your machine as well. So when we explore a new feature, I'll be adding some code to one of our projects, explaining what it does, and then running it. You should be doing the same on your machine, even though you're just watching what I'm doing and then doing it yourself. This is a bit of monkey see, monkey do, where you're just following along, but it's really important in order to understand what a new feature does. Now, when it comes to building up your problem-solving abilities, the monkey see, monkey do approach doesn't work. That's why in this class, I've included over 100 unique challenges requiring you to solve problems on your own using what's been covered in the course. So I'll set up the problem telling you what I'd like you to do, I'll give you some time to go off and do it, then together we'll work through the solution. It's really important that you do both of these. Follow along with the lessons and give the challenges an honest try. That's going to make sure that when you're done the class, you actually have the skills and experience to go off and build applications on your own. All right, let's go ahead and talk about how you can get help should you need it. We're about to spend a lot of time together learning something new, and it's likely that at some point in the class, you're going to need a little help. Maybe you're running the program we've been creating together, and you're getting different results. Or maybe you try to run the program and it completely crashes, printing some sort of cryptic error message. Regardless of what's going wrong, the course Q&A is your place to ask questions and get help. All that we ask is you provide as much information about your problem so we can help get you unstuck and back on track quickly. This includes a zip of your project code, screenshots of errors or results that you weren't expecting, and a description of what exactly you were doing when the problem occurred. Now, throughout the class, I'll also be teaching you how to debug your Node.js applications and read those error messages, but the course Q&A is always there should you need it. All right, that is it for this video. Let's go ahead and continue on with the class. This course contains a lot of new information, so to make that information a bit easier to digest and remember, I've included a PDF guide with the class. This is essentially a 112-page ebook, which contains lecture notes, code examples, and documentation links for everything covered in the class. Video is my favorite way to learn something new, but it's a poor reference tool. If you forget what something was called or where it was initially explained, it can be really hard to dig through hours of video to find that. The goal with the PDF guide is to give you that information in a way that's scannable, so you can easily find it and use it to do whatever you were trying to do. You can download the PDF guide as part of the lecture resources for this lesson. So take a moment to download it, crack it open, and see what it's all about. All right, that is it for this welcome section. Let's go ahead and jump right into the class. Welcome to your very first section for the course. The first video for each and every section is a little section introduction. This video is only a couple of minutes long, and it's where we come face to face to talk about what we're going to cover in the section and how that's going to fit into our bigger picture goal, which is to be able to create our own Node.js apps. So here's an example. In this section, you're going to get your machine set up for the rest of the class. We'll start by installing Node.js, and I'll set you up with a text editor that works really well with Node. All of that is going to allow you to write and run Node.js applications. We'll also talk about what exactly Node.js is and why it's something you should spend your time learning. So you're about to invest a significant amount of time learning this tool. It's a good idea to learn what exactly you're getting yourself into. I'm excited to get to all of that and more, so let's go ahead and jump right in to the first video. Before we talk about what Node.js is or explore why it's a useful tool, we're going to go ahead and install it. And the reason we're installing it first is because we're actually going to use a little bit of Node.js in this section to answer those two important questions. In this video, we're going to install Node.js. It's a super easy process, and we're also going to make sure you have a text editor on your machine so we can use it to write our scripts throughout the class. Let's go ahead and get started by installing Node. We can find it over at the official Node website, nodejs.org. Right here on the Node.js homepage, we have the download section for our operating system. Right here, I am indeed running on a Mac, and down below, I have two Node versions I could choose to install. On the left, I have version 8.12.0, which is the current LTS version. That stands for long-term support. And on the right, I have version 11.0.0, which is the current release with the latest features. And that's the version of Node we're going to work with throughout the class. Now, if you're seeing a more recent current version, please go ahead and install that. I'm frequently updating this course to always support the latest Node features. So as you move through the class, I recommend installing the newest version of Node possible. Once again, for me, that's currently 11.0.0. So I'm going to go ahead and click that big green button. That's going to download the installer, and it's one of those really easy click next installers. So let's go ahead and run through it. Right here, there's no need to customize anything we see. We'll click continue a couple of times. We'll agree to some stuff we're not going to read, and we'll choose where we want to install Node. From here, all we have to do is authenticate. I'm going to provide my password, and after just a couple of seconds, Node.js will be installed on your machine. And there we go. The Node installer is all done. It says that Node was successfully installed, and all we're going to do is test that by running a single command from the terminal on your machine. We're going to make sure that Node was indeed wired up correctly. To do that, let's go ahead and first close down the installer. We're all done with this. I am going to go ahead and move it to the trash. It is no longer necessary. And what we're going to do now is open up the terminal on our machines. On my Mac, I'm going to get that done by cracking open Spotlight and searching for the terminal application. If you're on Windows, you can use the Windows key to bring up the search bar and search for the command prompt application. If you're on Linux, the exact name and location is going to depend on your distribution. You're looking for something like the terminal, the command prompt, or the command line. Now we're going to go ahead and crack this open, and what we get, regardless of our OS, is the same thing. Stylistically, it's going to look a little bit different, but it is a place for us to type commands. We can then hit enter to run those commands, and we'll see the results right here in this screen. Now, when we installed Node.js, we didn't get a GUI application with fields and buttons and text. Instead, what we got is a command we can now run from the command prompt. We're going to be using this command hundreds of times throughout the course, and we'll learn a lot more about it and how it works throughout the class. For now, though, we're going to use it in one way to check for the Node version installed. So right here, we're going to type out 7 characters. To start, we will run the node command. So we're going to type out node, N-O-D-E, followed by a space, and we're going to provide an argument to this command telling it that we just want to know the version of Node that's running. So right here after that space, it is a hyphen followed by the letter V. Now, if we go ahead and run this, we are going to get the version of Node we just installed. Right here, I'm seeing version 11.0.0, which is indeed the version I installed a few minutes ago. Right here, you might not see the same version I have, but you should see the same version you just installed. Now, what if you're not getting that? Well, if you're not getting a version, that likely means Node wasn't installed correctly. And to simulate what this looks like, I'm just going to mistype Node. So I'll type Node with 2 E's as an example. Then I'll try to use this V argument to ask for the version, but there is no node command with 2 E's, so what do I get? I get an error saying something like command not found. If you're seeing something like this when you run the correctly spelled command, that means that Node wasn't installed correctly and that we need to address that before you can continue on. To do that, all you have to do is crack open a question in the course Q&A, and I'll work with you to get Node installed correctly. So at this point, we've installed Node.js and we've confirmed that we can actually use it on our machines, and that's where we're going to stop with the terminal for now. I'm going to leave the terminal open as we'll be using it in the next several videos. And if you don't have any previous terminal experience, don't worry. We'll cover all of the commands we end up running. No terminal experience required. That's all we're going to do with Node for now. To wrap up the video, I want to make sure we all have a text editor we can use to write out our Node scripts. So to do that, let's go ahead and explore a couple of different options. Throughout this class, I'll be using Visual Studio Code. You can find and install this over at code.visualstudio.com. Now, there are a few reasons I love Visual Studio Code. It is free, it is open source, and it's available for all operating systems, whether you're running on Mac, Windows, or Linux. It also has one of the best editors I've used in a while, with a fantastic ecosystem of extensions and themes, allowing you to really customize the editor to fit your needs. And we're going to do just that with Node.js. With Visual Studio Code, we can actually debug Node.js right inside of the tool, which is a great feature you don't always see from text editors. Now, there is no reason you have to use Visual Studio Code. It is just the editor I'll be using throughout the class. You're more than welcome to use any editor you're comfortable with. If you already have one that supports JavaScript, then you're already good to go. But if you're looking for something new and you want to try out what is a very cool tool, I definitely recommend checking out Visual Studio Code. Now, there are plenty of other options out there as well. In the past, I've used the Atom text editor in my classes. It's also a great free open source editor available for all operating systems. And there are some good paid editors out there as well. Examples of that would be Sublime Text 3 and WebStorm. Now, WebStorm is definitely more of an IDE than a text editor, but it's also a tool worth checking out. So all we need is to install one of these. If you want to follow along exactly and use the setup I use, I recommend installing Visual Studio Code. So take a moment to get that done. You can pause the video, then come back when you have it installed, and we're going to wrap up the course by just cracking it open. So I'm going to open up from Spotlight, Visual Studio Code, and right here, we're not going to actually do anything with the editor. I just want to make sure we have it installed and we can actually crack it open. So we have Node installed, we've checked that the command works, and we have a text editor where we can now write Node scripts. That is it for this installation video. We're now ready to continue with the rest of the course. In the next 2 videos, as I mentioned, we're going to focus on answering 2 important questions. What is Node.js, and why is Node.js a tool worth using? I'm excited to talk about both of those, so let's go ahead and jump right in to the next one. In this video, we're going to answer a single question, which is, what exactly is Node.js? Node.js came about when the original developers took JavaScript, something that at that point we could really only run in the browser, and they allowed it to run as a standalone process on your machine. So before Node, JavaScript just could not be used as a more general purpose programming language. It was limited to what the browser allowed it to do. So for example, I could use JavaScript to add a click event to this button or to redirect a user to a different page, but there was no way to use the JavaScript programming language outside of the browser to build things like web servers that could access the file system and connect to databases. All of these are things that other programming languages can do without any problem. All of this ended up changing with the introduction of Node.js. With Node.js, JavaScript developers could now use JavaScript on the server side, so they could use the same JavaScript programming language to create web servers, command line interfaces, application backends, and more, all of which we'll end up covering in the class. So at a high level, you know what Node is. Node is a way to run JavaScript code on the server as opposed to being forced to run it on the client in the browser. Now, the question has to be asked, how exactly is this possible? And we're going to explore the answer by starting with this 1-sentence summary on the Node.js homepage. We're going to read this out, break it down, and it's going to shed some light on what exactly is happening here. So Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. And it all comes back to this JavaScript engine. Now, there are all sorts of JavaScript engines out there. Pretty much every major browser has their own. Node.js uses the V8 JavaScript engine, and that's the same JavaScript engine that powers the Chrome browser. And V8 is a Google open source project. The job of the JavaScript engine, whether it's V8 or any of the other ones out there, is to take in JavaScript code and compile it down to machine code that your machine can actually execute. Now, the V8 engine is written in the C++ programming language. That means anyone out there could write a C++ application. They could incorporate the V8 JavaScript engine into their application, and they could extend the functionality that JavaScript provides. And that is exactly what both Chrome and Node.js do. Both Chrome and Node.js are largely written in C++. Now you'll notice right here, it says that Node.js is a JavaScript runtime, and that's true. Node.js is not a programming language. In the end of the day, all of the code we're going to write in this class is indeed JavaScript code. The runtime is something that provides custom functionality, so various tools and libraries specific to an environment. So in the case of Chrome, it provides V8 with various objects and functions that allow JavaScript developers in the Chrome browser to do things like add button click events or manipulate the DOM. Now, neither of those features make sense for Node, where we don't have buttons and we don't have a DOM, so Node doesn't provide those things. Instead, the Node runtime provides various tools that Node developers need. Libraries for setting up web servers, integrating with the file system so you can read and write from disk, and in the end of the day, both Chrome and Node.js are just creating their own modified version of JavaScript. Now, in the end of the day, it's still that same core JavaScript language, but with custom functions and objects injected. Now, this is actually a really important concept, so I've put together a quick visualization to walk us through exactly what's happening here. So let's take a couple of minutes to jump into that. As I mentioned, we have the Chrome browser, and the Chrome browser uses the V8 JavaScript engine. Now, when Chrome needs to run some JavaScript for a particular web page, it doesn't run the JavaScript itself, it can't. Instead, it uses the V8 engine to get that done. So it passes the code to V8 and it gets the results back. Now, the same exact thing is true with Node. Node does not know how to run JavaScript code. It also uses that V8 engine. So when Node needs to run a script, it passes that script down to V8, and in the end of the day, it gets those results back. Now, I mentioned that V8 is written in C++, and I also mentioned that both Chrome and Node are largely written in C++, and once again, that's no coincidence. The reason that both Chrome and Node use so much C++ is that they're both providing bindings when they're instantiating the V8 engine. This is what allows them to create their own JavaScript runtime with interesting and novel features. It's what allows Chrome to interact with the DOM when the DOM isn't part of JavaScript, and it allows Node to interact with your file system when the file system isn't part of JavaScript either. So V8 has no idea how to interact with the file system with JavaScript or what the DOM is. It is up to Node and Chrome to provide implementations for those when running V8. What does this process look like? Well, we have a table. It's not really a table, but it's convenient to think of it as a table. And we have a set of JavaScript methods and objects, and we have a set of C++ functions. So on the left, I've picked two very popular JavaScript methods. Here I have local storage.getItem, which would fetch an item out of local storage, and I have document.querySelector, which would allow me to query some elements from the DOM and then do something with them, like deleting them or changing their contents. Now, it might surprise you, but neither of these are part of the JavaScript programming language itself. You can pull up the specification, you can search for them, but you're not going to find them. That's because they're actually implemented by the Chrome runtime. When Chrome runs a JavaScript file that uses either of these, in the end of the day, some C++ code gets executed behind the scenes, which is responsible for taking care of the functionality. That's why Chrome has so much C++ code. Now, Chrome needs to tell V8 what to do when these methods are called, so Chrome's not just passing JavaScript code to V8, it is also passing down these C++ bindings, creating the context for which the JavaScript code should be executed in. Now, the exact same thing is true with Node.js. Over here, I've picked out a couple of Node.js methods that you'll be familiar with by the end of the next section. I have fs.readFile. Fs stands for file system, and readFile allows me to read the contents of a file from disk. I also have os.platform, OS of course standing for operating system, And the platform method allows me to fetch the name of the platform I'm running on, such as Windows, Linux, or Mac. Now, neither of these methods, once again, are part of the JavaScript programming language. They're provided to V8 as part of the Node.js runtime. So JavaScript doesn't know how to read a file from disk, but C++ does. So when someone uses JavaScript code in Node.js to read a file from disk, it just defers all of that to the C++ function that can actually read the file from disk and get the results back to where they need to be. So once again, we have a series of methods that can be used in our JavaScript code, which are in reality just running C++ code behind the scenes. Now let's wrap up this video by going over a little code example that illustrates some of the differences and similarities between JavaScript in the browser and JavaScript inside of Node.js. So to start, we're going to open up any website. I'm just going to use the Node.js homepage, and we're going to crack open the console. So from here, I'm going to go to Settings, More Tools, Developer Tools, and we're just going to pull up the Console tab. This is going to allow us to run individual JavaScript statements. So right here, as an example, I could type 2 + 3, hit enter, and I get the result 5 back. I could also create a string with my first name inside of it, the string Andrew, and I could use the string JavaScript method to uppercase to convert that string to uppercase, and I get uppercase Andrew back. Now we can do the exact same thing in Node. Almost all of the Node code we're going to write in this class is going to live inside of files in a larger project, and that'll happen over in Visual Studio Code starting in just a couple of videos. But for the moment, we're going to go ahead and just mess around with Node right here inside of the terminal. So let's go ahead and use clear. This is a standard bash command allowing us to clear the output we're seeing. If you're on Windows, you need to use CLS, that is the version of clear for your operating system. And what we're going to do from here is just run the node command. We're not going to put anything after it, just NODE, and we hit enter. Now what we get here is a little place where we can run individual node statements, also known as an REPL, which stands for read, eval, print loop. Like the terminal, it's waiting for us to run some commands, but these are actually going to be node JavaScript statements and not bash commands. So what are we going to do? Right here, we're going to write some JavaScript code and hit enter exactly like we did over here. And I'm going to use the exact same two things. 2 + 3. Enter. What do I get? 5. Then I'll create the string Andrew, and I'll use the string 2. Uppercase, calling it, and what do I get? I get back the uppercase string Andrew. So right here, we can see that all of the core JavaScript features we're used to are still available when using Node.js because those are provided by the V8 engine itself. Now let's head over to the browser and start to explore a couple of the differences. If you've worked with JavaScript in the browser before, then you're likely familiar with the window object. The window object is a reference to our browser window. I can type window, I can hit enter, that's going to dump the entire object to the console, and if we expand it, we can view all of the different methods and properties we have access to, and there are quite literally hundreds of them. Right here, we have some methods related to click events. I have onClick, onChange, and others. And if I continue to scroll down, we have things related to the window size. I have outer height, outer width, and others. Now, all of these make sense in the context of JavaScript in the browser because we actually have a window to work with. What happens if I try to get the window in Node? I'm going to type window, I'm going to hit enter, and I can see I'm getting an error, reference error. Window is not defined. So window is something specifically provided by the Chrome runtime when JavaScript is running in the Chrome application. Node doesn't have a window, it doesn't need window, so window is not provided. Now with Node, we have something kind of similar. We have a variable called global. Global stores a lot of the global things we're going to be accessing throughout the course. And if we scroll up, we can see we have dozens of different properties and methods available to us. We're not going to dive into any of these right now, but we will be exploring several of them as we start to learn about Node.js. Now, does the browser have global? The browser does not. If I scroll all the way to the bottom, I can run something new, type global, hit enter. What do I get? I get global is not defined. I actually misspelled it, but I'll get the same result if I do indeed spell it correctly. Global is not defined. Now there's another difference I'm going to point out before we wrap things up here. In the browser, I have access to document. Document allows me to work with the DOM. So right here, I have a whole bunch of different elements that make up my page, and I can use document to manipulate them in whatever way I see fit. Now this makes sense once again for the browser where we actually have a DOM. It doesn't make sense for Node where we don't have a DOM. If I try to print document to the terminal, what do I get? Once again, reference error. Document is not defined. Now in Node.js, we have something kind of similar to document called process. Process gives us various properties and methods for manipulating the node process that's running. If I dump this to the terminal, we can see there are all sorts of interesting methods and properties, including one, exit. Exit allows us to exit the current node process. Let's go ahead and actually use it to shut down our little node example right here. That's going to be process, which is an object, .exit, which is a method. I'm going to call it providing no arguments since it doesn't need any. And all we're going to do is run this statement by hitting enter. What do I get? I can see I'm brought back to the standard terminal where I could run other commands. No longer am I running little node statements. Now, process, once again, does not exist over in the browser. That is specific to Node.js. If I type out process and dump it, I get process is not defined. So here we're seeing some of the differences between JavaScript in the browser, here specifically Chrome, but other browsers would be the same, and Node.js, which is JavaScript running on the server. That's where we're going to stop for this one. Let's take a quick moment to summarize. Node.js is JavaScript on the server. This is possible because Node.js uses the V8 JavaScript engine to run all of the JavaScript code you provide. Now, Node.js is able to teach JavaScript new things by providing C++ bindings to V8. This allows JavaScript, in essence, to do anything that C++ can do, and C++ can indeed access the file system, so now JavaScript can access the file system through Node. That's where we're going to stop for this one, and don't worry about memorizing all of this. As we move through the course and start to see this in action, I'll bring up the individual pieces again. In the next video, we're going to dive into what is also a very important question. Why should I learn Node.js? I'm excited to get to that, so let's go ahead and jump right in to the next video. In the last video, we answered the question, what is Node.js? In this video, we're going to turn our attention towards the why behind Node.js. So why is Node.js a tool you should spend your time learning? And why is Node.js a good tool for the job of building out applications? Now, as you know, based off of the fact that you're here taking this class, more and more when people want to learn a new backend technology, they are choosing Node.js as their tool of choice. The Node.js skill set is in hot demand with companies like Netflix, Uber, and Walmart all using Node in production. Node's also useful for developers anywhere on the stack. So we have front-end developers who might need to use a little Node here and there to compile their apps or maybe serve up a website they're working with. And obviously, back-end engineers are using Node.js extensively to build out their web app backends, APIs, and command line applications. Now, in the last video, we broke down this first sentence. We talked about how Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. In this one, we're going to break down the other two sentences. There's only 3 total. We got this second one and the third one. Now you'll notice that you don't have those second 2 sentences on your screen. If I were to load up nodejs.org, I just get that first sentence we already discussed. In the past, this was the complete summary on the website, and I've cached it so we can talk about it. In my opinion, I think it's a shame they took it down because it concisely summed up why Node.js is an ecosystem worth getting into. Let's go ahead and start with that second sentence. Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient. Now let's just focus on non-blocking I/O. What exactly is I/O? I/O stands for input-output, and your Node application is going to use I/O anytime it's trying to communicate with the outside world. So if your Node app needs to communicate with the machine it's running on, that's I/O. For example, reading some data from a file on the file system. If your Node app needs to communicate with some other server, that's I/O as well. For example, querying a database to fetch some records for a given user. That's going to be an I/O operation, and I/O operations take time. Now with Node.js, we get non-blocking I/O. That means that while your Node application is waiting for a response, let's say a response from that database, it can do other things. It can continue to process other code and make other requests. Now, non-blocking is actually from the browser. So non-blocking I/O started in the browser because otherwise the browser would completely freeze up whenever an I/O operation was happening. So if I was trying to fetch some data to render it to a user, while that data was being fetched, the user wouldn't be able to do anything. They wouldn't be able to click links or buttons, and obviously that's a bad experience. With non-blocking I/O, it frees up the browser to allow the user to interact with the user interface while those I/O operations are running in the background. And the same thing is true with Node. We can continue to do other things while we're waiting for those long-running I/O operations to complete, and this is a critical feature of what makes Node so great. And I put together a quick visualization so we can compare non-blocking to blocking I/O. In this quick visualization, we're going to work through two code examples. Now, both code examples aim to get the exact same thing done, they just do it in slightly different ways. On the left-hand side, we have a blocking example. On the right-hand side, we have a non-blocking example. And there's no need to write any of this out, as we're just going to explore how these programs would execute using these timelines down below. That's going to allow us to visualize the differences between blocking and non-blocking I/O. Now, what do we have here? We have a bunch of regular JavaScript code. The only thing specific to Node.js is this require function, which is called on the first line of each little snippet. You'll learn all about require in the next section. For now, all you need to know is that it's a way to get functionality from another file. So in this case, both of these scripts, they load in a function defined elsewhere, and they call them a couple of times to perform some I/O operations. The I/O operation for both is attempting to do the same thing. So over here for the blocking example, the goal is to take in a user ID and then go off to a database and actually fetch that user's profile information. And we do the same thing over here in the non-blocking example. So to start, we try to fetch the user with an ID of 1, then we print it to the console. We do the same thing over here using a slightly different pattern, which we'll get into shortly. Then over here, we try to fetch the user with the ID of 2, and we print that to the console, and we do the same thing over here. Finally, both snippets attempt to add up two numbers and print that sum to the console as well, and that's all they do. Now down below, I have some units for each timeline. That's going to help us compare the relative operating speeds. They're not exactly seconds, but for the sake of this example, you can definitely think of them as seconds. And now we're actually going to run through each, seeing how they execute. We're going to start with the blocking example, and for both examples, we're going to ignore that first line. The first line is the same for both, and it's not part of this whole blocking versus non-blocking discussion. So the first thing we really do over here is we pass 1 into getUserSync. The goal here is to go off to the database and get the user profile for the user whose ID is 1. Now, what does that look like? Well, down below, it looks a bit like this. Here I have a block representing the time this entire operation takes to complete. And in this case, I've chosen to make the length of our I/O operation 2 seconds. And that's going to be the exact same length of all I/O operations in these examples, regardless of whether it's blocking or non-blocking. So this includes everything. It includes initiating the request and actually waiting for the database to fetch the data and send it back to our Node application. So once that's done, what do? We go ahead and just print user1 to the console. That is not an I/O operation, and it runs really quickly. From there, we continue working through our program one line at a time. We go one after the previous. So right here, what do we have? We have user2, and we get the second user by passing 2 into getUserSync. Once again, we wait 2 seconds to actually get that second user. Right here, these two blocks are the exact same length. The next thing we do is we go ahead and print that second user. That happens on line 7. Once again, not an IO operation. It runs really quickly. And the same thing is true of the last thing we do, which is we calculate and print the sum. So this is the order of operations, and this is the entire time it takes to run. In this case, let's say it's basically 4.5 seconds. Now you'll notice the bulk of this 4.5 seconds is taken up by fetching second user and fetching first user. And while that's happening, our app isn't doing anything. It's waiting for the database to send the data back. It's not actually doing any work on its own. Now let's go ahead and run through the example on the right to see how this differs even when the IO operations still take 2 seconds. The first thing that happens over here is the same thing that happened over here. We are attempting to fetch the user with the ID of 1. So what does that look like? Well, you'll notice that over here, we're actually passing a function in as our second argument to get user. This is using the callback pattern, and if it's something you're not familiar with, if this code looks really foreign, that is a-okay for the moment. We're actually going to cover all of this in detail in the class. For now, we're just using it to illustrate at a high level the differences between the two patterns. So over here, what do? We start to fetch the first user. Now, the first thing you're going to notice is that this is not a 2-second operation. It happens basically instantly. That's because we're not waiting for the response from the database. That's the long-running I/O. Instead, we are just starting that process, allowing it to run in the background. So right here, we are essentially registering our I/O event with Node.js, telling it to call this callback when at some point in the future, we get the response we were hoping for. Now, the same thing is true down below. So the next thing we do is we actually start the process of fetching the second user exactly like we did up above. So at this point, Node is actually waiting for 2 long-running I/O operations to complete, and they're both happening in the background. It's not taking up our application's time, preventing it from doing other things. And we can prove that by talking about the next step. The next thing that happens is we actually calculate and print our sum. These 2 lines down below, they do not care about the user response for either user 1 or user 2. They should be able to operate completely independently, and that's what we're seeing right here. There's no need to wait for those 2 responses before calculating and printing the sum. Now what happens? Well, I mentioned that regardless of which example we're working with, the I/O operation doesn't get shorter. It still takes those 2 seconds. So right here, I have a box of the exact same width as our 2 boxes over here, and it's a dashed box, and it represents the time our Node app has to wait for a response to come back. Now, the nice thing is that while it's waiting, it can still do other things. So while it was waiting for user 1, it was able to start up another request, and it was able to calculate and print the sum. Now, after those 2 seconds, we still get the user data back. This is when Node.js calls our callback function, and we are able to print the user, and that's what I see right here. Next up, we wait for that second request. This starts just a little bit later than the first, and it finishes a little bit later. And once we get that data back, we are able to print the second user to the console. If we look at the total operating time, I can see that the non-blocking example was able to finish in just over 2 seconds, while the blocking example was able to finish in just over 4 seconds, a difference of 50%, making the non-blocking example twice as fast. Now, obviously, that's because we were able to overlap the part of our application that took the longest, which was waiting for the I/O to finish. Down below, we were able to wait for both at the same time, and while we were waiting, our app could even perform other things like firing off another request or calculating and printing the sum. That just is not possible using a blocking model. So in this course, we're going to be working with non-blocking code throughout the class, and that's what makes Node so ideal for things like server-side development, where we're making web servers and application backends. It's going to allow your Node app to process multiple requests at the exact same time for different users. So you could be fetching some data for user 1 while processing a new request from user 2. Now let's go ahead and run some Node code to actually see these two examples in action. Right here, I'm going to put on a quick demonstration actually running the two files we just had over in that visualization. On the left, I have my blocking example, character for character, what I had in the other file, and the same thing is true on the right with the non-blocking example. Once again, you don't have to worry about opening this project up or writing this code. This is just for demonstration purposes. We'll start diving into coding together in the next video. For now, what we're going to do is run these two scripts to see how they execute, which is going to be exactly how we described them in the visualization. On the left-hand side, I'm going to use one terminal for the blocking example. On the right-hand side, I have a second tiny terminal for the non-blocking example. Now, to actually run a file, we still use that node command, followed by a space and the file name. So here, node space blocking.js is the file I'm trying to run. Now, to make things easier to see, I've delayed the I/O operations to take 5 seconds, so it's a bit easier to talk about things as they're happening. Let's go ahead and kick off the blocking example. So what happens? Nothing. We are sitting here and we are waiting for a full 5 seconds before that first user comes back. There it is. We have their ID and their name. Then we wait another 5 seconds to get the second user. Finally, the sum prints exactly as we saw over in the visualization. So 5 seconds for Jess, 5 more seconds for Mark, then basically instantly after Mark printed, we got 34 printing. So this is the blocking example for a total runtime of just over 10 seconds. Now let's try the non-blocking example. In this case, getting the user still takes a full 5 seconds. So right here, node space, the file non-blocking.js. I'm going to go ahead and run it. And once again, we get the number printing right away. It started up the two I/O operations. It printed the number. Then 5 seconds later, both basically printed at the exact same time. That's because we were able to overlap the process of our Node app waiting. So the total runtime here for our non-blocking example was just over 5 seconds, once again, running twice as fast as the blocking example over here. So that is it for our little illustration of blocking versus non-blocking. We're going to talk a lot more about this a bit later in the class when we start to get into some more advanced Node.js application code. For now, though, we have done a pretty decent job at exploring this second sentence. Node.js uses an event-driven non-blocking I/O model that makes it lightweight and efficient. So we now know what non-blocking I/O is, and we've seen that it definitely creates a more lightweight and efficient application. And event-driven is just that process of registering those callbacks and having them called when the I/O operation is done, and it's something we will talk about in detail later on in the class. The last sentence we have here, Node.js's package ecosystem NPM is the largest ecosystem of open source libraries in the world. Now, NPM is a tool that was actually installed on your machine when Node was installed, and you can find the website at npmjs.com. Here, a website we'll be spending plenty of time in the class. You can search for all sorts of pre-written packages that you can use inside of your application. So if you want to validate emails, there's a package for that. If you want to send emails off or communicate with a database or create a web server or pretty much do anything else you can do with Node, there are libraries and packages that make your life much easier. We're going to make heavy use of NPM packages throughout this class, which is exactly what real developers do when they're building out Node applications. This is something we'll start to explore in the very next section. So we know a little bit about what Node is and why it's a tool worth learning. In the next video, we're going to wrap up this little introductory section by actually creating and running a script on our own. I'm very excited to get to that, so let's go ahead and jump right in to the next video. In this video, you're going to create and run your very first Node.js script. Now we're going to keep it simple for the moment. This is actually the last video in this little getting set up section. In the next section, which starts in the next video, we'll move on to explore Node in detail, and we'll start to build out meaningful applications. For now, the goal is to just give us a place to even put our code, and we're going to figure out how to run our scripts. Let's go ahead and kick things off by actually closing down the terminal. The terminal, or the command prompt on Windows, is not something we're going to use throughout the rest of the class. Instead, I will be using the integrated terminal built right into Visual Studio Code, so we don't have to switch between windows. I'm going to close that down, and let's just get a bit organized. On the left-hand side, I'm going to put the browser. That's where this will stay for the rest of the class. And on the right-hand side, I'm going to put Visual Studio Code. Now the goal is to give us a place to put all of the files and folders we'll end up creating for our projects throughout the class. Right here, I'm going to expand the tree view, and you'll notice that there is no folder open. So let's go ahead and create one, and then we'll open it. I'll be using the File Explorer for my operating system, which is the Finder, to create a new directory. And you could put that directory wherever you wanted to. I'm going to put mine right on the desktop. So right here on the desktop, I'll be creating a new folder, and I'm going to call this something like node-course perfect. This is the location where we're going to put all of the stuff we write in this course. And this is the folder we're going to open up in Visual Studio Code. I'm going to shut down the Finder and open up that directory. Right here on the desktop, I have my node course folder, which I'll double click. This is going to open up that directory in Visual Studio Code, which I can see based off of the window title and the folder title over here. Now we can actually add files and folders to this directory to build out our projects. Now, as I mentioned, we're going to keep things pretty simple in this video. We're going to have a one-line script just to make sure everything is working correctly. So let's go ahead and create it. Right here in the node course folder, I'm going to create a brand new file, and we can call this whatever we like. I'm going to call it something like hello.js. Remember, Node.js isn't a programming language. In the end of the day, all the code we write is JavaScript code. So right here, I'm using a .js extension exactly like I would if I was creating JavaScript files that I intended to run in the browser. As the first and only line in this file, we're going to use console.log to print a message to anyone who runs the script. So right here, we'll be accessing the console object. We'll be using the log method on there, calling it as a function and passing in a single argument right here. That is the string, something like welcome to the class. Now you should be familiar with all of this since the basics of JavaScript are indeed a prereq for this class, and there we go. We now have a simple Node script. Now you might say, hey, this really isn't a Node script, this is a regular old JavaScript script, but it's important to note that console.log, it's not actually part of the JavaScript programming language. This is always part of the runtime, whether that comes from a browser like Chrome or Node.js. So there's no better time than now to show you where the Node docs live. Over at nodejs.org, we have this docs page up top. On the left-hand side, I have two API pages for the two versions shown on the homepage. I'll click on mine. Then down below, I have a long list of different modules we can work with. This one, the one that we just used, is called console. I'm going to expand that, and what do we get? We get all sorts of different ways we can use console, and down the list, we do have the one that we just used, console.log. So the documentation for Node is a great way to get comfortable with the features, and we'll be referring to it a lot throughout the rest of the class. Right here, though, we can see that console.log is something provided by Node, and if I click that, it brings us down to some examples as to how we can use it. Now let's go ahead and actually run our script to see our little message print to the screen, then we'll be done with this video. As I mentioned, we are going to use the integrated terminal throughout this class. It makes it really easy to run terminal commands from right inside of Visual Studio Code, and you can find it by going up to the terminal menu and clicking New Terminal. Also take a moment to note the keyboard shortcut. I'm a huge fan of keyboard shortcuts, so for me on a Mac, it is Control-tilde. I can just type that from anywhere to crack open a new terminal, and here I have it. Now we're already navigated to the correct location. Here I'm running commands from inside of the Node course folder, and you should see that as well. And what we're going to do is use that node command once again. Now in the past, we had used node just like this to run individual statements. When we have a script we want to execute, we use space, and then we provide that script name. So right here, node space hello.js, matching up with the file name we created. Now we can actually execute this little node application by hitting enter to run it. And what do I get? I get my message, welcome to the class printing, and this is fantastic. That's where we're going to stop for this one. We now have a place to put our projects and our project files, and we know how to run node scripts. So we're done with this video and we're done with this section. In the next section, we're going to dive in and start to learn how to use Node.js to build out backend and server-side applications. I am beyond excited to get to it, so let's go ahead and jump into the section introduction for the next one. Welcome to section 3. In this section, we're going to be diving right into Node.js, and we're going to start to create our first of 4 projects. That is a note-taking application. Now, in this section in particular, you're going to learn how to use one of the most fundamental features of Node, that is the node module system. So Node.js comes with all sorts of cool libraries, also known as modules, that do a lot of interesting things. For example, if you want to read and write from the file system, or connect to a database, or start up a web server, you need to know how to use the node module system to load those modules in. In addition, you'll learn how to use the node module system to load in modules written by other developers, and you'll learn how to use the node module system to load in modules that you yourself have created. All of this is going to allow us to load functionality into our application so we can use it to do interesting things. I'm excited to dive into the section, so let's go ahead and jump right in. Welcome to your very first programming video for the class. From here on out, we're going to be spending our time writing code and building Node applications in Visual Studio Code. Now, in this video in particular, to kick off the course, we're going to talk about one of the most fundamental features of Node. This is the module system, and this is what's going to allow us to take advantage of all of the cool and interesting things that Node provides. So as an example, over here in the docs, there are all sorts of modules listed. Now some, as we saw with console, are available globally, which means we don't have to do anything special to use them. Right here, as an example, we just accessed console.log to use it. Others require us to actually load them in before they can be used in our scripts. That's exactly what we're going to explore, and the module we're going to use to explore this is the file system module listed down below. This is the module that's going to allow us to access the operating system's file system. We'll be able to read and write, append files, and figure out if a given file or directory exists. All sorts of interesting utilities related to the file system. The table of contents here contains all of the interesting ways we can use this module inside of our Node applications, and if we start to scroll down, we can see there are quite literally hundreds of different ways. Now at some point, we're going to get to a part in the table of contents where everything starts with fs dot, followed by some method name. Here, as an example, I have fs.access. All these methods are listed in alphabetical order, and we're going to scroll down to the method we'll be using, which is fs.writeFile. This is the method that's going to allow us to write some data to a file on our file system from the Node.js application. Now we have 2 versions of this. I have fs.writeFile and fs.writeFileSync. The first one is an asynchronous version, the second one is a synchronous version, and for the moment, we're going to stick with the synchronous version. Don't worry though, we will be exploring asynchronous Node.js in detail in just a couple of sections. For now though, the goal is to learn about this module system. So fs.writeFileSync takes in 2 arguments, the name of the file you want to write to, and the data you want to write. So let's go ahead and use it. I'm going to head over to the Visual Studio Code editor, and I will take a moment to delete hello.js, as this is not going to make it into any of our applications. Let's go ahead and trash it. And we'll make a brand new folder for our first project, which is going to be a little notes app. So I'll call the folder notes app, and in there, we're going to make a single JS file right here, app.js. Now down below, inside of the terminal, I am going to switch directories from node course to notes app by using cd space, then the folder name notes-app. Now we're actually running commands from that directory, and that's great because we're going to run node in just a few seconds. Let's go ahead and actually use fs.writeFileSync. Exactly like we saw in the docs, it is fs, which is an object, dot, the method name is write file sync. It is indeed a function, so I am going to call it as such, setting out my parentheses, and as I mentioned, this takes two arguments. In this case, both are strings. The first is the name of the file, the second is the data to write. Let's go ahead and pick a name for our file, and I'm going to call this something like notes.txt. So for the moment, we're going to stick with a simple text file, though later on we'll learn how to work with files of other types. Now the second argument is going to be the contents to put in that file. So right here, as a string, let's go ahead and write out a little message. This file was created by Node.js. Perfect. So now we actually have a call to write file sync, and we can go ahead and run this script. The problem is that it's not going to work. Down below, let's prove that. I'm going to use node to run a script. After a space, the script name is app.js, which is indeed in the directory we're running commands from, the notes app directory. If I go ahead and hit enter, we are not going to see any sort of output that suggests that things went well. Right here, we have a very long error message. It contains information about exactly where the error occurred and what exactly is going wrong. Now later in the course, when we explore debugging, we'll really break down errors like this. For the moment, the only important piece is this little message right here. fs is not defined. So the problem is that we're using fs. Fs, though, needs to be loaded in and defined. The file system module, as I mentioned, has to be required by you in the script you're using it in. So right here, we're going to add a second line. Before we use the file system module, we're going to go ahead and load it in, and this is done using the require function that Node provides. And this is at the very core of the module system. The require function is how we load in other things, whether it's a core Node module, another file we created, or an npm module we've chosen to install and use in our projects. To load in the file system module, we have to call the require function, which is indeed how we load in modules, and we pass to it a single string. Now, when we're looking to load in a core Node module, we just provide the name of the module, and for the file system, it is fs. Now, the require function returns all of the stuff from that module, and we have to store that on a variable. Right now, fs still doesn't exist. So right here, we're going to create a constant called fs, and its value is going to come from the return value of calling require. So let's break this down. We're calling require, which is going to load in the fs module. The fs module is built right into Node, so this is going to work for any Node script. What do we do with the return value? We store it on the fs variable. Then down below, we call fs.writeFileSync to write some text to the notes.txt file. Let's go ahead and see if this works. Down below, I'm going to start by clearing the terminal output using the clear command. If you're on Windows and you're using the standard command prompt, you're going to have to use cls, which is the command for you. And now we're going to go ahead and run the app script again. So node space app.js. This time, what do we see? We see nothing. It brings us right back to the command prompt, asking us to do something else. But you'll notice that over here in the tree view for the notes app directory, we have a brand new file right alongside of app.js. We have notes.txt, which got its name from this argument. And if I crack it open, what do we have? We have our little message. This file was created with Node.js, which is fantastic. Now let's go ahead and switch up the text we're writing and run the script again. So over here, I'm going to change the text value for that second argument. Go ahead and do the same. I'll switch it up to something like an introduction. I'll say, my name is Andrew, period. Perfect. Now we can rerun the script to write some new contents to that file. Down below, I'm going to use the up arrow key to cycle through my previous commands. Here, the previous one we ran was node running app.js. Then I'll hit enter to run the script again. Once again, nothing outputted down below, but if I open up notes.txt, we have our new text content showing up, which is great. So the write file and write file sync methods, those are responsible for writing data to a file. If the file doesn't exist, as we saw, it'll be created. If the file does exist, as we just saw, its text content will be overwritten with the new provided message. I want to take a quick moment to note that this variable, fs, it could be called anything we wanted. The only important thing is that the string we pass to require matches up with what Node calls the module. Otherwise, Node is not going to know which module you're trying to load. So as an example, I could call this something like file system, and that would be perfectly valid as long as I changed my usage down below to file system as well. Now we have a different name for the variable and the program would work, though it's common to stick with the convention. For all Node modules we load in, there's typically a variable name that everyone uses, and it makes life easier if we all stick with that variable name so we can know what exactly we're working with across projects. Now, if you're wondering how I knew to load in fs or what the common variable name is, or whether the module even needs to be loaded in at all, once again, the docs are your best friend. If we go back over to the documentation and scroll down past the table of contents, one of the first things we're going to see is what we have on line 1. Here, we can see exactly what Node calls the module. Based off of the fact that this code is here, we know it needs to be loaded in, unlike console, and then they have a common used variable name, which we can choose to use or choose to ignore, though once again, it is typically a best practice to use the name, in this case, fs. So at this point, we have loaded in our first core Node module and we've used it to do something interesting. Now I want to take a moment to move on to our first challenge for the class. Whenever I write code in a video, you should be following along as well. I film all of the videos in real time so you can actually write the code I'm writing. That is a great way to learn something, but it's not the best way to make sure you can actually use that information to solve problems. So throughout the course, in almost every single video, I have a challenge where you're going to need to solve a programming problem based off of what you just learned. The goal here is to give you as much real-world experience as possible actually using Node.js on your own. By the end of the course, you'll actually have a ton of experience writing your own code and building your own apps, and you'll find it much more comfortable to go off after the class and actually use Node.js, whether you're building your own side project, trying to get into freelancing, or trying to switch careers and become a Node.js developer. So it's important that you follow along with the lessons. For example, you should have this code in your editor. It's also equally important that you take the challenges seriously. So here's how they work. I give you a prompt, I give you a second to pause the video, you go off and solve the problem, then you come back and I walk you through the solution. So let's go ahead and jump into our very first one. As always, I'm going to paste in a little description of what I'd like you to do. So this is a pretty standard challenge. Now, they're going to start off easy and they're going to get harder over time as we actually know more about Node and we can do more things. Right here, challenge. Your goal is to append a message to notes.txt. So I don't want to override what's here. I want to add something new on to the end. How are you going to do that? You're going to use a new method from the file system module called append file sync to append to the file. Once you've added that in, you're going to run the script, and finally, you're going to check your work, making sure that the new text you append is showing up on the end right here. Now to do that, we are going to comment out our existing fs.writeFileSync call. We're going to add just that one call in, the call to append file sync. And if we head over to the documentation, you can learn more about that. I'm going to scroll up back to all of those modules and methods we were looking at earlier. And if I go all the way up to fs dot and I go to the A's, I have append file sync right here. Now, append file sync works much the same way as write file sync. It needs the name of the file you're trying to append, and it needs the text content you want to append. So in the end of the day, we want to append to the file whose name is right here, and you can pick whatever message you want as the text to append. You could add to the introduction saying something maybe about where you live or how old you are. If the concept of a challenge seems a little foreign to you, don't worry, we're going to go through this about 100 different times throughout the course, so you'll be pretty comfortable with it by the end. And as I mentioned, things are going to start off easier as we know less about Node, and the challenges will get more complex, requiring you to write many lines of code as we progress through the class. For now though, take some time to knock out all 3 steps down below. You can pause the video. When you're done, come back and click play. How'd that go? Very first challenge down. Hopefully it went well. If it didn't, that's okay too. This is really an introduction to challenges, and once again, we'll get more comfortable as we do more of them. Right here, the goal was to use fs.append file sync. Now this is already a module we have loaded in, so there's no need to load it in again. Right here, we can call fs.append file, and you'll notice that since we've loaded in the FS module with Visual Studio Code, at least I am getting some helpful suggestions about which methods I have access to. Right here, I will be using append file sync and calling it as such. Now, what file am I trying to append to? Well, I only have one. It is notes.txt, so that will be the value I provide for the first argument, and for the second argument, I'm going to provide the text I want to append. I'll say something like, I live in Philadelphia. Perfect. Now, since we're appending one string right on to the end of the other, I'm going to put a space at the beginning of the string so I have a space between the period up here and the letter I down below. Now we can go ahead and save app.js and run our script to test things out. I'll use the up arrow key and enter to rerun the previous command. And if I open up notes.txt, what do we have? I have my old message, my name is Andrew, and I have my new message, I live in Philadelphia, which is excellent. And there we go. You've completed your very first challenge. Once again, these are essential to getting real-world experience, solving problems, and working through your misunderstandings. So it's okay if you don't get them all right, or it takes you a lot of time to figure out what's going on. It's going to get easier to recall what we covered as we use it more and more. Now that we're starting to write code together, I wanted to remind you that the lecture resources for every lesson of the class contains a zip of the code up to that point. So if you're getting stuck and you can't quite figure it out, you can always download the zip for that lesson that contains all of the code changes made, and you can compare your code with my code. You can also head over to links.mead.io/node course to view a GitHub repository that contains every piece of code created in the class. That's where we're going to stop for this one. We've now loaded in and used our very first core Node.js module. In the next video, we're going to continue to talk about the module system and require. I am excited to get to that. So let's go ahead and jump right in. In the last video, you learned how to use the require function to load in a Node module. In this video, you're going to learn how to use the require function to load in another file you've created. So right now, the only file that's ever going to execute is app.js, because that's what we pass to the node command. That means we're going to have to put everything in this file if we want it to run, and that's not ideal. As our applications get larger and more complex, we're going to have way more code than we would want to have in a single file. When all of our code sits in one file, it makes the project really hard to expand on and maintain. So from the start, we're going to go ahead and create projects that use multiple files so we can stay organized. We can do something like define a function in one file, then require it into a different file and use it. And that's exactly what we're going to end up doing in this lesson. To kick things off, we're going to completely empty app.js. I'm going to delete everything we have inside of here. And we're going to start with a very simple, bare bones example to illustrate how all of this works. Then we'll create something more complex using the fs module once again. For the moment, let's go ahead and define our name as a variable. So const name equals, then as a string, your first name. Next up, we're going to go ahead and print it. Nothing groundbreaking here. Console.log, providing the one and only argument, a reference to the name variable. Now, if we run this program, we know exactly what's going to happen. Down below, I'll rerun the script, and what do I get? As expected, I get my message, Andrew, printing to the console. Now let's add a second file into the mix and try to define this variable in that second file. Over inside of the Notes app directory, we have to add a new file into our project. And it's important that you make sure you actually put it in Notes app and it doesn't end up in the root, which is the node course directory. So right here, I'll right click on the Notes app folder. I'll add a new file and we'll call this something generic like utils.js. And let's just say this is a file which contains a few useful utilities for the rest of the application. Now, all we're going to do inside of here for the moment is use console.log to print a little message. And we're going to print the file name, utils.js, so we can figure out exactly when this file runs. Now, if we were to go ahead and run app.js, we would not see that log statement. Down below, we can prove that. I'll rerun the script. I only get my Andrew message. I do not get the message over here. So when we pass a file to Node, only that file executes. If we want another file to run, we have to require it for that file to actually get loaded in. We can do just that. Up above, I'm going to add a line at the very top of the file, and here we're going to use require. I'm going to call the require function exactly like we did in the last video when we were loading in the fs module, and we're still going to pass in a single argument, a string. Now, when we're loading in a file that we created in our application, we start with // We have to provide a relative path from the file we're loading it in from, in this case app.js, to the file we're actually trying to load, in this case utils.js. So from app.js, it is // which gets us to the folder for this file. That would be notes-app. From there, we can just go right to the utils.js file, which is located in the same directory. Now, when you're loading in a JavaScript file like this, it is indeed going to execute that file. I'm going to save app.js, and we're going to rerun the program. Down below, I'll rerun our app script, and what do I get? I get utils.js printing first because require happens up here, and that's when utils runs. Then down below, I get Andrew because that's a bit further down the file. But the good news is that I am indeed getting both messages, one from app.js and one from utils.js. So there we go. We now have an application, albeit a simple one, that takes advantage of multiple files. From here, let's go ahead and start to define some variables in that other file that we use in app.js. So as we create complex applications, we'll have all sorts of functions we'll define in other files, and we'll want to use them in our application's main file, which in this case is app.js. So let's see what that looks like. To do this, all I'm going to do is remove the name variable from app.js. So right now, the program would fail because we're trying to reference this variable that doesn't exist. Over in utils.js, we're going to recreate it. So right here, a new const name equals, we're going to pick a value for this. I'll switch things up just to see the different output down below, and I'll stick with Mike as my string for name. Now we're going to save both files and see what happens. So we load in utils.js, which defines that variable. Then we reference the variable down below. Down below in the terminal, I'll use clear to clear the terminal output, and I'll use the up arrow key twice to cycle past the clear command to the node app.js command. We're gonna run it, and it's gonna fail. When I do, what do we get? Name is not defined. So this is one very important aspect of the node module system. all of your files, which you can refer to as modules, have their own scope. So app.js has its own scope with its own variables, and utils.js has its own scope with its own variables. App.js cannot access the variables from utils.js even though it was loaded in with require. So if I can't access name right now, how exactly do I get that done? The answer is that we need to explicitly export all of the stuff this file should share with the outside world. To do this, we take advantage of another aspect of the module system, which down below is module.exports. This is where we can define all of the things this file should share with other files. Now, in our case, it's going to be one thing, a string. Later on, though, it's going to be an object with a bunch of different methods on it, allowing us to export a whole bunch of things. Whatever we assign right here is what gets exported. So all we're going to do is export whatever the value is for name, which we know is the string Mike. So at this point, utils.js is doing its job well. It defined a variable and it exported that variable. Other files can now take advantage of it. Whatever you assign to module.exports, that is available as the return value from when you require the file. So I require utils.js right here, which means the return value is what I assigned, the string Mike, which is stored on this name variable. So over here in app.js, I'm going to create a constant. I'm going to pick a name for our new variable. Name seems appropriate enough. And now our program is back to a working state. Let's go ahead and save app.js and test that out. With all of our files saved down below, I'm going to use clear to clear the terminal output, and I'm going to use the up arrow key twice to rerun the script. And what do I get? I get my utils.js message, which was expected, but I'm also getting Mike, which is fantastic. It's getting printed in this file, but it's getting defined over here. We were able to use module.exports to export it, and we were able to load it in over here with require. Now, once again, just because I picked the name over here doesn't mean I have to use that over here. They are completely independent. I could call this something like first name, a completely different variable name, and that would work just fine as long as I change the references down below too. Right here, I'll change those references, I'll rerun the program, and what do I get? I get the same results. The app is still working. So whatever we assign to module.exports is what other files can get access to. Now let's go ahead and look at a slightly more real-world example where we export a function. The function that we're going to create will be defined in utils.js. It'll be exported from that file. It'll be loaded into this one and called down below. In utils.js, let's go ahead and define it right here. Below our name variable, which we can leave in place, we're going to create a new function, and I'm going to call this one something like add. We're just going to make a simple function that adds up to numbers right here. We will indeed define a function. I'm going to set up two arguments. We can call them X and Y or A and B. Any two names would work. And all we're going to do is return the sum A plus B. So a very simple function. The point isn't to make interesting functions just yet. The point is to figure out how to share functions across files. Now down below, we can export it. So currently we're exporting name. We're no longer going to do that. Instead, we're going to set module.exports equal to right here, the add function. Now, what do we know? We know that what comes back from require is now this function, which means that over here, the name first name doesn't make much sense anymore, and neither does how we're using it. We need to call it since it's a function. So right here, I'm going to call that add, which is indeed appropriate, though remember, it could be called anything as long as we're consistent in this file. Down below, we can now go ahead and use it. I am going to create a variable, sum. I'm going to get its value by calling add. I'll pass in 4 and -2. The sum should be 2, and I'll print the sum to the screen. So right here, sum, perfect. Let's go ahead and save all files and see if this works. Down below, I'm going to rerun the script, and what do I get? I get my utils.js method followed by the number 2. So in this case, we exported a function from one file. We then loaded it in with require in a separate file, and we were able to use it, which is a fantastic step in the right direction. Now it's challenge time, and it's going to be up to you to create a new function in a new file and use it in app.js. For the moment, we can go ahead and completely empty this file, or you could choose to leave it around as a reference for the future challenge. If you want to do that, you can just comment out each of the lines. There's a handy keyboard shortcut. It is Command / on Mac and Control / on other operating systems. I could highlight all of the lines here, use that keyboard shortcut to comment them all out. Then I could just move them down below, leaving them in place as a reference to remember how things work. Now I'm going to paste in the challenge comments, and we'll talk about what I'd like you to do. So big picture goal. You want to define and use a function in a new file. So step 1, you're going to create a new file called notes.js, and this is a real file we're actually going to use as part of the notes application. From there, you're going to create a getNotes function, which is also going to be a real function we'll be building out throughout this course. Now, for the moment, it's not going to do anything fancy. It doesn't need any arguments, and it's not going to run any calculations. All it's going to do is return a static string, like your notes ... The notes will eventually come later. Step 3, you want to export the new function from the new file. Step 4, from app.js, you want to make sure you can load in that new function, call it, and print the message to the console. So in the end of the day, app.js should be requiring the new notes file. It should be calling that function to get the message, and it should be using console.log to print that message to the console. When you're done, you should run the program, and the message should print down below. Once again, as these challenges get more complex, it's okay if something's not quite clear or you're not quite sure how to do something. You can always go back to the video in the beginning and figure out exactly what happened. That's not cheating. That's called being resourceful. Actually memorizing things will come with time. All right, let's kick things off. Take a moment to pause the video. When you're done, come back and click play. How'd that go? Hopefully that wasn't too much trouble. We're going to go ahead and kick things off right now by creating that new file. Step 1, create a new file called notes.js. I'm going to put that right in the Notes app folder, notes.js, and we need to define a new function that returns the string your notes. The function should be called getNotes. Let's get that done. Const getNotes equals a brand new function. And all that function is going to do is return the string, your notes, ... Later on, it'll do much, much more. Now, step 3 is to make sure that this function actually gets exported. So export the getNotes function. Right now it's defined, but it's not exported, so no other file could take advantage of it. Right here, we're going to fix that. I'm going to use module.exports, which we used in utils.js. I'm going to set it equal to the thing I want to export. In this case, it is the getNotes function. Now, notes.js is all done. Everything else is going to happen in app.js. We have to load in the file, call the function, and print the message. Let's do that right here. I'm going to create a variable const. I'm going to call this getNotes. I'm then going to use require to load that file in. Right here, inside of require, we pass in that string. And remember, when we're loading in another file we've created, we have to provide a relative path from the file we're calling require in to the file we're trying to load. So ./notes.js, and now we can actually use the getNotes function. So right here, const message equals, I'll be calling getNotes. I don't have to pass in any arguments since it doesn't take any, then console.log to print the message to the console. Perfect. Let's go ahead and see if this works. Down below, I'm going to go ahead and rerun the script, and what do I get? I get your notes ... printing, which is fantastic. Now that we have this in place, we're making good progress in the right direction, and we can go ahead and remove all of the commented out code in this file, leaving just those 3 lines in place. We're also going to remove the utils.js file that was created for demonstration purposes. The file that you created, notes.js, that's actually going to stay around and play a critical role in the Notes application. So now we know how to load in core Node modules. We know how to load in other files we've created. The last thing we need to learn about is how to load in NPM modules so we can take advantage of them in our applications, something we'll be doing extensively throughout the class. We're going to talk about that in the next video. I'm excited to get to it, so let's go ahead and jump right in. You now know how to use the node module system to load in core node modules like the file system module and other files you've created, like notes.js. In this video, you're going to learn how to use the module system to load in NPM packages. This is going to allow us to take advantage of all of those awesome NPM modules from right inside of our Node applications. There are an endless amount of awesome, useful NPM packages that we can install, so we don't have to recreate the wheel from scratch. There are things that pretty much every application out there needs to do. Examples would be validating data like emails and maybe even sending an email. These are core functionality, not specific to what your application does for your users. So if we use NPM modules to solve common problems, which is indeed the standard in the Node community, then we can spend our developer time focusing on the awesome features that make our app unique. So as I mentioned a bit earlier in the class, when we installed Node, we also got the NPM program installed on our machine. This gives us access to everything over at npmjs.com, which we'll head back over to in just a few moments. Now, before we can actually use any of these modules in our script, we have to take two very important steps. One, we have to initialize NPM in our project. Then two, we have to install all of the modules we actually want to use. So let's go ahead and see how that happens. First up, let's initialize NPM in our project, which means we have to run a single command from the project root. That root directory is the Notes app folder, so make sure you're running commands from there. In the terminal down below, I am indeed accessing that directory. Now, when we first installed Node, we got the version of Node we were using by using the node command with the v flag. When we installed Node, we also got access to the npm command line tools. We can run that with the v flag to get the version of npm we're running, and right here, you can see I'm running version 6.4.1. Now, the specific version of npm you're using does not matter, as long as you're using version 5 or greater. So as long as that first number is either 5 or higher, which it should be, you're good to go. Now, from here, we have to initialize npm in our project, and we do that by running a single command from the root of the project, npm init. This command is going to initialize npm in our project, and in the end of the day, it's not going to do anything fancy. It is simply going to create a single configuration file that we can use to manage all of the dependencies from the npm website that we want to install. So right here, we're going to go ahead and run npm init. Now, it has a lot of information telling us exactly what's happening. In the end of the day, what's really going on is that npm is asking us for some information to populate various fields in this configuration file. Now, we can type out custom answers. So for example, the first piece of information it wants is just a name for our package, so some sort of name for this project. Now, by default, it uses the folder name Notes app. We can choose to use that by just hitting enter, or we could type something custom to override that value. For every single question it asks, we're going to stick with the default value. So we have package name. I'm just going to hit enter. We have version, we have description, entry point, test command, get repository, keywords, author, and license. Now, there are a few of these fields we'll be exploring in detail later. We'll talk about testing when we explore testing, and we'll talk about the get repository when we set up deployment. Many of these fields, however, are for folks who are creating NPM packages, which is not what we're doing. We're creating an application on our own, and we're trying to consume NPM packages, so the values for many of these are not important for our purposes. Right here, we can hit enter on that last one, and it's asking us if things are okay. Now, what exactly is it doing? Well, it tells us it's about to write a package.json file to the notes app directory. Down below, this is the exact contents it's about to write to that file. Everything looks good. We can type yes to confirm that we want npm init to actually create that file, and now we have a brand new file in our project root. If I crack it open, we can see that as npm promised, it looks exactly like what we had outputted in the terminal down below. The extension for this file is JSON, which stands for JavaScript Object Notation, and as you can see, it looks a bit like a JavaScript object. There are a couple subtle differences we'll explore as we use JSON throughout the class. It's something we're going to be covering in great detail. For now, all you really need to know is that you have to use double quotes instead of single quotes, and all of your property names, like name or author, they also need to be wrapped in quotes like we're seeing here. If I were to remove the quotes from one of our property names, like license, this would be valid in JavaScript, but we can see it's invalid in JSON, so let's go ahead and bring those back. Now, this file is going to be used to manage all of the dependencies that our application needs to run. So in here, we're going to list out all of the npm packages we want to use. To start, let's go ahead and move to npmjs.com and find a package we actually want to work with. Now, for this example, we're going to install the very popular validator package, which gives us all sorts of awesome tools to perform data validation. So right here in the npm search bar, I'm going to search for validator. And we're looking for that first result, the validator package. Now, there are other validation packages out there. There's even one with a capital V. We want this first result, lowercase validator. Now, when we click that, it's going to bring us over to the npm package page. This is a great page. Every npm package has one, and it gives us a ton of information about the package. We have the documentation for how to actually use it, and on the right-hand side, we have a bunch of great stats about the package. Things like the version number, the GitHub homepage, and the weekly downloads. This is a very popular package with over 1 million weekly downloads. So if you wanted to perform a little validation in your Node app, there are two ways you could go about that. The first approach would be to write all of the validation code yourself. You have to write the code, you have to maintain it, you're going to want to write test cases for it to make sure there are no edge cases, and in general, you're going to have to keep up with that code as Node progresses over time. Now that's option one. Now, when you're creating an application, I doubt that validation is what makes it unique. So if I'm creating a weight loss application, as an example, I likely have some sort of reason why I'm doing it. I have a model about either diet or exercise or habits that's going to help people lose weight in a way they weren't able to before. What makes my app unique is likely not how it validates emails. So sure, you could write that code, but it's a much better practice for a lot of these basic features to take advantage of a well-tested npm package like this one, where millions of different applications and utilities are taking advantage of it all the time. Now, that's not to say we're not going to write code. We are, but for some things, we're going to take advantage of other packages that allow us to get it done in a much more secure way. So in this case, the validator package has all sorts of tools for validating emails, URLs, phone numbers, social security numbers, credit cards, and other types of string information like that. Let's go ahead and install it and see how it works. Now, what we're going to do is note the package name because that is essential. You can actually see a command over here that we can run to install it. Right here, lowercase v validator is the package name that we need, and we're going to head over to the terminal and install this. Now, we want to run the command we're about to run, once again, from the notes app directory right here. That's npm install validator. Now, you'll notice on the website they used npm I validator. Those are identical. I is just a shorthand for install. You are more than welcome to use either approach. Now from here, we're going to specify the specific version we want to install. So then the version number. I'm going to be using the latest version currently available, which is 10.8.0. In this course, I'm always going to specify package versions to make sure that we're always on the same page. NPM modules do change their APIs over time, so to ensure the videos always work, I'll be locking us into specific packages, including updates when APIs change. So right here, this is the command we want to run. Now, when we run this, what's it going to do? Well, it's going to go off to the NPM servers. It's going to grab all of the code for that package, and it's actually going to add it into our application. And we'll notice that when we ran that command, two things happened. One, we got a package-lock.json file, and two, we got a new directory, a node modules directory. Let's take a quick look at both. First up, node modules. This is a folder which contains all of the code for the dependencies we installed. So if I crack this open, what do we have? We have a single directory validator. That's the package we installed. And if we open that up, it's all of the code for the validator package. Now, the node modules directory is something we should not be manually editing. We should not go inside a validator and actually change these files. And we'll talk more about that as we progress through the course and learn more about package management. When it comes to working with node modules, it's just going to get generated and edited when we run npm install commands. So we use npm install, and npm maintains this directory. The same thing is true with package-lock.json. This is a file which contains extra information, making npm a bit faster and a bit more secure. It lists out exact versions of all of our dependencies, as well as where they were fetched from, and we also have a SHA hash, making sure that we're getting the exact code that we got previously if we were to install a dependency again. Once again, this is not a file we should ever be editing. Once again, this will be maintained by npm. So we have our package installed, and when we ran that command, it was even added to package.json. We have a dependencies property, we have our dependency name, along with the version we installed. Now that we have it installed, we can move into our node app, a file such as app.js, and actually load it in with require and take advantage of some of the functionality it provides. To load in an npm package, we once again use require. I'm going to add a second require statement to this file. Right here, we're going to go ahead and use require like we did previously, and we are indeed going to pass in a string. Now, for those core node modules, we typed out the module name. For our files, we would start with // to provide the relative path to the file. For npm modules, we list out the npm package name. So in this case, that would be validator, and this is similar to what we do with those core node modules. Now, require is going to return all of the stuff that the validator package provides us. So right here, I can create a variable like validator that's going to store the contents that comes back from require. Now, when it comes to figuring out how to use a given package, this is when you just have to turn to the documentation to figure out how it was intended to be used. We're going to end up looking at the documentation for every tool we install. I like to point you towards the documentation since that's going to give you all of the information you would need to learn more about how something works or to explore other ways a given tool can be used. Now, for our purposes, on the npm package page, we have all of the different ways that this tool can be used. If we scroll down to the validators section, we have a method and we have a description of how it works. There are maybe 100 different methods for all sorts of different things we can do. One of the methods is email. This allows us to determine if a given email is valid, and that's something we are indeed going to take advantage of. This method can be accessed directly on validator, which is an object. So let's go ahead and test this out. I'm going to add a console.log call down below so we can print some output to the terminal. And instead of creating a variable and then passing that into console.log, I'm just going to call the function right inside of console.log. So right here, validator dot the method name, that's isEmail, and we're going to pass in to that method call a single string argument. So right here, let's go ahead and try something like andrew@example.com, which should indeed be a valid email as it contains all of the component pieces. Now let's run our application. From the terminal down below, I'm going to clear the output using the clear command or CLS on Windows. Then I'm going to run node with app.js. When I do that, what do I get? I get my first piece of information from line 5, then I get true, which is coming from line 7. So here we have a valid email. Now let's switch that up. I'm going to remove Andrew and the @ sign, leaving just example.com. I'll save app.js again. I'll rerun our script, and this time we correctly get false. The information passed in is no longer a valid email. So is email returns true if the string is an email, it returns false if the string is not. And there we go. We were able to install an NPM package, load it into our Node application, and take advantage of it to do something meaningful. Before we wrap this one up, let's go ahead and explore one more method. Right here, we have an alphabetical list of methods. I'm going to scroll down to is, and we're looking for U for is URL. Right here, we have another method allowing us to determine if a given string is a URL. So let's go ahead and test that out. I'm going to remove is email, something we'll be using later in the class. I'm going to swap it out with is URL. Then I'm going to change the string value I provide. Let's go ahead and try my own site URL, https://mead.io. I'm going to save the file. I'm going to rerun the program, and this time we get true. Now I'm going to mess that up. Maybe I'll do something like remove one of the colons and the /. I'll run the script again, and what do I get? I get false. This is indeed an invalid URL. Now, when it comes to taking advantage of the documentation for a given package, it's usually best to find an example. Sometimes the documentation itself doesn't really make it clear how something is to be used. Up at the top, though, we can see there are real examples similar to what we just did inside of our own project. Now you'll notice there are two versions here, no ES6 and ES6. This is a Node course that uses ES6, ES7, and more modern features throughout. The only big difference here is that up above we're using require, which is what we're using in Node, and down below they're using a slightly different syntax using the import keyword. Node currently does not support the import keyword. Support is coming for it later down the line, and when it is supported, I'll add a section covering it, but for now, in Node.js, when we want to load something in, we use require. So right here, this would be a great example to kind of help us figure out exactly how the package is intended to be used. That's where we're going to stop for this one. We have installed the package, we've required it into our file, and we've used it. In the next video as a challenge, you're going to end up doing the same thing for a different library. I'm excited to get to that. So let's go ahead and jump right in to the next one. In this video, as promised, you are going to get a bit of experience working with an NPM package on your own. Before we get into the challenge, though, I want to take a quick moment to talk about node modules, the directory that NPM created. This is a generated directory, so that means that NPM generates it, and it's not something we should be manually editing, because when we use the npm command again, our edits are going to get overwritten. You can actually recreate this directory from scratch using npm based off of the contents of package.json and package.lock.json. So if you were to download a zip for this course, or you were to grab the code from the GitHub repository, which contains all of the course code, you'll notice that the node modules directory is nowhere to be found. So let's experiment with this by actually deleting it from our local project. I'm going to remove that folder, and this is exactly what you would see if you grabbed the lecture zip for the last lesson. It's the same files, but with no node modules directory. Now, the node modules directory is necessary for our app to run. When we require an npm library, it's going to look in that node modules folder for the application code. So if I were to run app.js right now, it would fail. Let's do it just to see. So node space app.js. I'm going to go ahead and run this command, and what do we get? We get a nice error message right here. Error, cannot find module validator. So it's complaining that we're using this module, but it's unable to locate it. So clearly we do need the contents of that node modules folder. The answer is, how do we get it back? All we have to do is run npm install. We're not going to provide any specific packages afterwards. This is the exact command. When we do this, it's going to look at the contents of packagelock.json and package.json to determine which dependencies and which versions our application is using. It's then going to recreate that node modules folder from scratch based off of just the contents of these two text files. So for larger applications, the node modules folder can get really, really big. So you might want to delete it if you were to share the code with a friend, or if you were to add it to your own GitHub repository. You can always get that folder back when you download the project by running npm install. So right here, I'm going to run that command, and it's going to regenerate node modules based off of the contents of our JSON files. Right here, we can see that we still have the validator folder inside of there after recreating the directory. And once again, our app is back to its working state. Node space app.js, I run the script, and we do indeed get the correct results. So when you download the code for this course, make sure to run npm install from inside of the project you're working with before you try to run any of the scripts. And now let's jump into the core of the video, which is going to be a challenge for you. You're going to install, require, and use a brand new npm library. Let's go ahead and talk about which one you're going to use. I'm going to head over to the npm search bar. The library you're going to use is called Chalk, like sidewalk chalk. Right here, we can pull up the package page, and you can see that this one is even more popular than the validator package we used before. This one gets 15 million weekly downloads. It is a very popular utility for all sorts of Node applications. Now, what exactly does Chalk do? Well, if we scroll down on the package page, we can learn a bit more about it. Chalk is a little utility that allows us to customize how text gets printed to the console when working with Node. So here, for example, this is the default styling. With Chalk, we can override that. And that can be a very useful thing to be able to do. Imagine you're creating a web server using something like Express, an npm package we'll be exploring later in the class. You might want to customize how you print logs for your server. Maybe you print errors in red or with a red background, and maybe you print success messages in green while you print warnings in yellow. Using a simple tool like Chalk, you can create better applications that make it easier for people to figure out what exactly is going on. So it's going to be your job to install it and use it inside of our little app.js script. Over in Visual Studio Code, before we talk about what I'd like you to do, let's remove our console.log call with our call to validator.isURL. And let's also remove that require on line 1 where we load the validator library in. Now down below, we're going to talk about the challenge for this one. And right here, I have all of the comments that's going to show you how to get this done. So big picture goal, use the Chalk library in your project. Now that's going to require you to do a few different things. First up, you're going to have to install it. You want to install version 2.4.1 of Chalk. Now, if you forget the command, that's okay. That is the entire point of these challenges. It's to give you experience so you build that muscle memory. You can refer to the previous video to look up that command, or better yet, crack open the PDF guide, as that is a very easy way to scan between lessons and figure out exactly what was covered. It includes code snippets as well as command line commands that we covered in the lesson. Step 2, you're going to load Chalk in using require, just like we did for validator. So that could happen up here on line 1, just before our require call to load in notes. Then you're going to use the Chalk library to print the string success into the console with green text. So green text would look a bit like what we have over here, though the exact shade of green will depend on your operating system and other display settings. Now, once you have that done, you're going to test your work. So you want to run our script after saving it, and you should see the green text success down below in the terminal. Now, if you're wondering how you're supposed to get this done, considering you've never used the library before, that's where the documentation comes into play. Maybe you're saying, hey, Andrew, I bought the course so you could teach me these things. And well, we're going to cover a ton of packages in detail, learning exactly how they work and how you can build complex apps with them. The goal is to also give you a bit of experience here and there, learning how to use new tools on your own, and I'll show you, once again, how to actually solve the challenge afterwards. It's important to build up this experience so when you're done with the class, you can go off and explore all of the interesting and awesome things that NPM has to offer. Down below, there's some example usages. Here they are printing some text in blue, so you can use this as a starting point. And if you were to scroll down through the documentation, there's a styles section, which gives you even more insight onto the various modifiers and colors that are available to you. So take some time to really explore the docs and figure out how to solve this challenge. When you're done with that, you can always use the bonus to experience a bit more of what Chalk has to offer. Use the docs to mess around with other styles, such as making the text bold, seen here, or inversing the text where the color becomes the background. So here that would be green inversed as an example. Just take some time to mess around with a few other ways Chalk can be used. As always, we're going to work through all of the solutions together. So if you get stuck or you can't quite get something, that is a-okay. All right, pause the video, give this your best effort, and when you're done, come back and click play. How'd you do? Let's go ahead and walk through the solution together. So step 1, we want to install this library. I already gave you the exact version number and the module name, which means down below, from the Notes app folder, we can run npm install, providing that package name. So right here, we are installing a new library, so we do indeed list it out. Chalk, like we did in the last video. Then we use the @ sign to provide the version 2.4.1. Now we can go ahead and run that command, which is going to install Chalk and all of its dependencies. Once we have that done, we can move on to step 2 and actually load it in. Now, when it comes to loading it in and using it, this is where the docs come into play. Right here, I can see that I can load it in and use it like so. So let's get that done. Up above on line 1, though it could have been below this line, I'm going to create my constant called Chalk, and I am going to load in the library by using require. Remember, for NPM packages, we load it in by providing its name inside of the string we pass to require. Now we have access to all of the utilities that Chalk exports, and we can go ahead and take advantage of them. And in this case, our goal is to print the success message in green. So right here, we're going to get that done, and it all starts with a console.log call. What are we going to do? I'm going to call another method inside of there that is Chalk dot followed by the color. So this is one of the things you have to discover for yourself. Right here, they used chalk.blue, but I wanted you to print things in green. If you scroll down, they have even more examples like chalk.red, which you may have seen, and they even use chalk.green right here. So all we have to do is use chalk.green. That's a method, and we're going to go ahead and provide our string, which is indeed the string success. Whoops, let's go ahead and be successful at spelling success. Now, once again, remember, you could have created a variable first and passed that in. That would have been a perfectly valid way to solve the challenge as well. Right here, for example, I could have created a const called green message, setting it equal to whatever comes back from our call to chalk.green. And then I could have passed green message in. Both of those would have been identical solutions in terms of functionality. Now let's go ahead and test our work. I'm going to save app.js. From the terminal, we need to rerun our script. That is node space app.js. And what do I get? I get green msh is not defined. So here I have a small typo. Clearly, I meant to reference the green message variable. So all I need to do is replace msh with msg, matching up with the variable name up above. Now, I could have stopped the recording and gone back and refilmed it pretending to be perfect, but that's not the point. The point is to actually solve problems and work through our issues, becoming better developers along the way. So every once in a while, sure, I'll leave my errors in. Now let's go ahead and save the program again after typing the variable name correctly. I'm going to rerun the script using the up arrow key and enter, and here I am indeed getting my success message printing in green, which is a fantastic step in the right direction. Now, when it comes to the bonus, there really is no right or wrong way to solve that. The goal was to just mess around with another styling option or two. And if you head over to the example documentation, you can see that there is a line where they chain things together. Now here they call chalk.blue.bgred.bold to create text that's bold on a red background where the text itself is blue. So we can go ahead and use bold with our current setup to create bold green text. Now the order you put things in doesn't matter, so it could be bold first, then green, or green first, then bold. Let's prove it. Chalk.bold.green. I'm going to save the program. I'm going to rerun things. The program works and we do get our bold green text. Now let's remove bold and one of the extra dots and put it after green. So here I'm going to call chalk.green.bold, calling bold as a method. If we call bold as a method and rerun the script, we get the exact same result. So here we can chain together exactly what we need to create any sort of styling we want, giving us a nice set of options. We could add a third style into the mix alongside of green and bold. Now, maybe you tried to use inverse. If you scroll through this example, which is a great way to figure out how to use a library, you'll notice that inverse doesn't actually exist here. They use things like underline, they use underline there and down below, but there's nothing related to inversing the colors. If we scroll down a bit though, we can actually pull up the API docs. If we go back down to that styles section, we can see all of the style modifiers and all of the colors available to us. Right here, there's another option called inverse. Let's go ahead and actually use it just to see what happens. Now, once again, I could add inverse first, in the middle, or at the end. I'm just going to toss it right here. So we have chalk.green.inverse.bold. All this is going to do is make the green color the background, and if I run the script, that's exactly what we get. So there we go. We have completed the challenge successfully. I'm going to remove those challenge comments, and we now know how to use NPM libraries in our project, which is a good thing because we're going to use NPM libraries throughout the course to create our back-end APIs, real-time apps, and more. Now, there's just one more way we're going to explore how we can install and use NPM modules, and it's going to make our lives a lot easier. So let's go ahead and jump right into the next video. In this video, you're going to learn how to install and work with global NPM packages. These are going to allow us to get a new command we can execute from the terminal. So far, all of the packages we've worked with are known as locally installed packages. That's when we install the dependency explicitly into our project, like we've done with Validator and Chalk in the Notes app project. You can tell it's a local dependency because it's listed in package.json like our two dependencies are. Now, local NPM modules, those get loaded into your project code with require, like we've seen with Chalk and Validator. When we install a module globally, we actually don't load it in directly to our source files. Instead, we install it globally, and it gives us access to a new command we can use from the terminal. Now, in the case of this video, we're going to install a NPM module globally that is a really nice utility for working with Node because it's going to allow us to run our application and automatically restart the app whenever the app code changes. So I can make a change up above and save the file, and we'll immediately see the results down below. So we won't have to constantly switch to the terminal and rerun the same command over and over again. We can find the package we're going to install by heading over to npmjs.com and going up to that search bar once again. Right here, the package we're going to use is called nodemon. That is Nodemon. Right here, the first result is the package we're looking for. And I'm just showing you where this package lives in case you want to learn more about it. It's actually a very easy tool to use, so let's just get right to it. The first thing we have to do is install it. Now, when we're installing a module globally, the installation command is basically the same with one slight difference. So let's go ahead and get started. Down below, we are going to run a command, npm install, the module name, that's nodemon, at 1.18.5, and this is the exact format you'd expect if we were to install the module locally. The only difference is we use the G flag, which is short for global. This is going to install the module globally instead. Now let's go ahead and run this command and see what happens. When the command finishes, we're going to notice that node modules, package lock.json, and package.json haven't changed in any way whatsoever. When we install a module globally, it is not changing the individual project, it's installing the tool on our operating system itself. So right here, it is going through the process of getting everything set up. Now we're done. And if I open up package.json, what don't we see? We don't see nodemon listed as a dependency. So it's not something we would ever require in our project and then actually try to use. This particular package wasn't designed to be used like that. Instead, what we got access to was a brand new command from the terminal. Now, when you install an npm package globally, things can indeed go wrong. I usually get a ton of questions related to this since everyone's environment is slightly different. If you are running on Linux or Mac and you're getting an error, I recommend putting sudo, that's sudo, in front of the command to run it as an administrator. So that would be sudo npm install nodemon at 1.18.5 with the G flag. If you're on Windows and you're getting some sort of error, just crack open a question in the course Q&A and I'll work with you to get unstuck and back on track. We can always verify that nodemon was installed correctly by running nodemon, the package name exactly, followed by the v flag, exactly like we've done with node and with npm. When I run it, what do I get? I get a version 1.18.5, the exact one I specified in my installation command. If you're seeing a version, that's great. If you're not, that means once again something went wrong, and you can always crack open a question in the Q&A and we'll work with you to get the global modules working correctly. So we have access to this new nodemon command, and the question is, how exactly do we use it? Well, let's explore that. First up, I am going to clear the terminal output to make things a bit easier to read, and all we do is we run our script like we would have with node, but we change the command we're using. So in the past, we use node space app.js to run the script once. With nodemon, we use nodemon space app.js. So the only thing we've changed is we've swapped out node for nodemon. Now if we run it, we're going to see our script run with a few additional pieces of output. Right here, we can see it's starting nodemon and it lists the version as well as some other logs saying that things are getting started. Then we do indeed see the 2 lines that come from our script. Down below, we can see that the program has exited and it's waiting for changes before it restarts. So now nodemon is up and running, and you'll notice it's not bringing us back to the command prompt even though our program has finished. The nodemon process is still executing. And if we change something up above, we'll see that change instantly printed below when we save the file. So I'm going to change chalk.green over to chalk.red, and then I'm going to change the message from success to error. If I go ahead and save the program, down below, I can see that basically instantly nodemon restarted the script, and now we see the new output from our program. We're still getting the your notes message, and now we're seeing our error shown in red. We could continue to make changes to our program and see those changes instantly reflected. I'll switch this to blue, save the program, and before I'm even done saying I saved it, blue is showing up down below. So throughout this class, I will be using nodemon, and I also use it with my client projects, so we don't have to constantly restart the node script every single time we make a small change. It is a great utility just to improve your overall developer experience. Now, if you want to stop nodemon, you can do that by going to the terminal and using Control-C. That's going to terminate the nodemon process and bring us back to the command prompt where we can do something else, like install a new module, maybe run the script once with node, or maybe restart it with nodemon in the future. All right, that's where we're going to stop for this video, and that is also the end of this section on the node modules system. You now know how to load in core node modules, how to load in your own files, and how to load in npm modules. This is going to give us a foundation for the rest of the class where we're going to do those things over and over again. In the next section, we're going to start to explore command line arguments and the file system, and we're actually going to work to build out that notes application. I am excited to get to it, so let's go ahead and jump right into the section introduction for the next one. Welcome to section number 4. In this section, you're going to continue to learn how to work with Node's module system. So in the last section, we ended up working with a few little scripts to explore this functionality. In this section, we're going to start to put all of that together to create the Notes application. Now, throughout the section, we'll be talking in detail about two important things, the file system and command line arguments. We'll be using the file system to store users' notes, and we're going to use command line arguments to get input from the user. Now, don't worry, later on in the course, you'll learn how to store user data in a database, and you'll learn how to get input from the user via the browser, but this is a great place to get started, so let's go ahead and jump right in to the section. In this video, you're going to learn how to get input from the user into your Node.js application, and this is going to be essential for creating anything meaningful. So think about the Notes application. If I'm the user and I'm trying to use the Notes app to add a new note as an example, I need to provide some information about that new note, such as a title and a body. The same would be true if I'm trying to use this Notes application to remove a note. I have 15 different notes. I need to provide some information about which note I want to remove. Now, for the moment, we're going to handle getting input from the user via command line arguments. Later on in the class, as we get into Node.js with web servers, you'll learn how to get input into your Node application from a client such as a browser. For now, though, let's go ahead and get started with the fundamentals of getting input into your app with command line arguments. Let's go ahead and get started in the terminal. So down below, I'm going to use clear to clear the terminal output. And all we're going to do is run our script through the node command with one slight modification. So node space app.js, we know exactly what this does. We get our your notes message and our blue success message. Let's go ahead and run that same command. This time though, after we're done, we're going to type another space followed by a value. So for the moment, let's just use something like our first name. I'll type mine in, Andrew. Now we're going to run the program again, and what do we get? The program still works. We get the exact same output. The only difference is that we've now provided additional information that our program could choose to use to do something dynamic, like print a greeting with that name inside of the message that prints. Now the question is, where exactly do we access those command line arguments? And the answer is that they're on that process global variable we explored in section 2. In section 2, if you remember, we took a little time to illustrate some of the differences between JavaScript in the browser and JavaScript running in Node.js. I talked about how the browser has window and document, and how Node has global and process. Well, on process, there is a property, and that's where we can access all of the command line arguments passed in to our app. Let's start by dumping them to the console. So right here, console.log process. Remember, process is a big object with dozens of different methods and properties. We're looking for one specific one. It's called argv, and that's in all lowercase. Argv stands for argument vector, and in the case of Node.js, it's just an array that contains all of the arguments provided. Right here, I'm going to save app.js, just dumping all of the arguments to the console. Then we're going to rerun our script with Andrew appended. So right here, I'm going to rerun the script, and what do I get? I get my 2 pieces of output that were expected, and I get my 1 new array. This is the value for argv, and what do we have? We have 3 strings inside of there. Now there are 3 strings, and 2 are always provided. The first one is the path to the Node.js executable on your machine. Now this is obviously going to be different for each and every user. The second is the path to our app.js file. Once again, this path is also going to be slightly different depending on where exactly the file lives on your machine, but both of them should be paths to those 2 locations. The third is the value that we actually provided. Right here, we have the string Andrew, which means that we could take advantage of that in our program to do something meaningful. Let's go ahead and extract the individual value out of that array. So process.argv is the array. We want to grab an item from the array by its index. So I'll use JavaScript's bracket notation to get that done. And we put the index right inside, where 0 is the first one, 1 would be the second one, and 2 would be the third item. Right here, this is exactly what we want. Now, if I were to save the script and rerun things, we wouldn't get this long array with a lot of useless information. We just get our one piece of useful information. We have the string Andrew, and we could now use that to customize our program. Now, in the case of the notes application, we're going to use this first value after the script name to actually determine what action we want to take. This will be known as our command. Am I trying to add a note? Am I trying to read a note or remove a note? What sort of action am I trying to take when running the program? So for example, right here, node space app.js space, I could do something like add, which would let the program know my intention is to add a new note. Right here, I can see that add now prints, and I could use this to run the right code. Let's see what that would look like. So up above, I'm going to remove all of the code except for our two require calls. Those are going to stay as we'll continue to use them. And all we're going to do for the moment is create a variable called command, and we're going to get its value from what we just printed to the console. That's process.argv, grabbing the third item by index. Now we could actually use an if statement to conditionally run some code. If the user who's running the app provided add, we could run the code necessary to add a note. Otherwise, we won't try to add a note. Right here, if. We'll set up our condition and the code block to run if that condition passes, and we're just going to check if command equals, using triple equality, the string add. If it does, we know the user is trying to add a new note, and we could run the code necessary to create the note and save it to our data store. For the moment, we're just going to console.log, a little message letting us know this code actually ran. I'll say something like adding note. Now if I save the program and rerun, what do I get? I get adding note printing, which is fantastic. Now we could also run this with a different command, for example, node space app.js space. Let's go ahead and use something like remove to remove a note. If I run this, you'll notice I'm not getting any output because I haven't set up the program to actually do anything when that's the provided command value. I could always address that by setting up an else if statement, checking if command equals the string right here, remove. If it does equal remove, that's great. We'll go ahead and run all of the code to get the removal done. Console.log right here, removing note as a temporary placeholder. Now we could save the program, we could rerun things again, and there we go. We now support that second command, allowing users a way to add notes and to remove notes. From here, let's figure out how to get even more information for each command. So knowing that the user is trying to add or remove a note is a good start, but if someone is trying to add a note, I need the note's title and I need the body. If someone is trying to remove a note, I need the title, as an example, of the note that should be removed. So how are we going to get that done? Well, once again, we're going to start with the command we've been using throughout this section. So right here, node app.js add. Then we're going to provide command line options like you've probably seen with other command line tools. So -title could be where we set the title. I'll set that equal to, inside of double quotes, the following, this is my title. I could run the program, and now we're passing in even more information. It might not look like it, but if we were to dump argv to the console, once again, we would see it. Console.log, process.argv, just dumping the entire array. I'll rerun the program exactly as we had it with title set up, and now I'm getting as the third argument add, which we already had, and as the fourth one, I am getting title. Now, one thing you'll notice here is that it's not something that gets parsed for us. We have the exact text typed out over here, as we do here, minus the double quotes. We need to now add some code to manually parse that. We have to figure out, for example, if title was actually provided. If we do see that title was provided, we have to get the value. Now, sure, we could go ahead and write all of the code necessary to parse those arguments. It would result in maybe 12 of the most uninteresting videos in this course, where we didn't talk about Node.js at all, but just talked about string parsing. Now, we're not going to do that, and for a couple very good reasons. One, we would have to write, test, and maintain all of this code, and that code doesn't do anything unique. Parsing command line arguments is not unique to our application, so it would be best to look for an NPM package that can take care of that for us, so we can get back to the task of writing what does make our application interesting, which is in this case its ability to manage your notes. So in the next video, we're going to look at how we can use a tool to parse process.argv, making it much easier to set up our arguments for our Node.js applications. I'm excited to get to that, and that video will include a challenge, so let's go ahead and jump right in. In the last video, you learned how to get input from the user via command line arguments in your Node.js application. We saw that all of the arguments provided to Node are passed through into our application, and we can access them via process.argv. Now, as we were exploring this, we also saw that we don't necessarily get these values in the most useful way possible. Node doesn't provide any argument parsing. It's a very bare bones utility, allowing us to just access the raw arguments. So when I provided this title option with the value things to buy, it wasn't parsed in a way that's particularly useful. I would need to write some code to extract the key and the value from this string, something we're not going to do because most Node.js applications use command line arguments in some way. And there are a ton of great NPM packages out there that are going to make it really easy to set up our commands and options as we want. And in this video, we're going to explore one of them called Yargs. That is Y-A-R-G-S. Let's head over to the browser. Here I have my one tab on npmjs.com. I'm going to go ahead and search for that Yargs package. And right here, it is the first one. Yargs is a pirate-themed application, which is where the Y in Args comes from. And it is a fantastic utility with about 21 million weekly downloads. So it is a widely used, well-tested tool that we can easily integrate into our application. Now you might be saying, hey, I thought this was a Node course and it seems like we're using a lot of packages. We already saw that Node doesn't provide a ton of argument parsing, and at this point, that is intentional. Node has left it up to the community to create various packages, each with their own way to solve the parsing problem. You can then go out and pick the package right for you, and Yargs is one of my favorite, and it happens to also be one of the most popular. So let's go ahead and install it into our project so we can make use of it. From the Notes app directory, npm install, I'll be using I, which is the same thing, it is an alias. Then the module name Yargs, and the latest version, that is at 12.0.2. So we're going to go ahead and install this into our application, then we'll be able to use it to better parse our command line arguments. All right, everything was installed down below, and I'm just going to take a quick moment to clear the terminal output. Now let's take advantage of this in app.js instead of manually looking at process.argv on our own. The first thing we have to do is require it. And once again, I like to go core modules first, we have none, then npm packages, then our own files. So right here, I'm going to load in another npm package alongside of chalk. We're going to call this variable Yargs, and we are going to get it from the return value of using require to load in the Yargs library. Now we can actually take advantage of it, and that process is super easy. What I'd like to do is do a little comparing and contrasting. So to keep the output simple, I'm going to remove this command variable for the moment, and I'm going to remove our if conditions down below. And all we're going to do is print out process.argv. Then down below that, we're also going to log out something from Yargs. It's yargs.argv. So this is the version of process.argv that Yargs has parsed. Now we can see exactly how the two are going to differ. So let's go ahead and start by running our script. Node space app.js, and we're going to run it with nothing additional. What do we get? We get a lot of information for the first version, the one that Node provides, and Yargs provides almost nothing. Here we have an object with two properties. We have an underscore property, which will get populated with various arguments in a little bit once we actually add them, and we have $0, which is the name of the file that we executed. So let's go ahead and actually add some arguments into the mix and see how Yargs is going to help us. Right here, I'm going to set up the add command, and I'm also going to set up that option once again. So -- title equals, inside of double quotes, a name for some note. Let's use things to buy, maybe it's some sort of grocery list. And if I go ahead and run this, now we're really going to start to see some of the advantages. So the first array from Node itself contains what we've already seen before. We have information that's not too useful. We have our command and we have some unparsed option. Down below, what Yargs provides us is much more useful. Our command shows up in the underscore property right here, add, and we have an actual title property on this object that contains the string value. So Yargs did all the heavy lifting of parsing our options and putting them on this object so they're easy to access. I could access the title property to do something with it, like create a new note and save it to our data store. Now, this is the most bare bones way to use Yargs since we haven't configured it to do anything special. By default, though, we actually get some pretty useful behavior. To explore that, let's go to the terminal down below and clear the terminal output. We're going to run our script, so node space app.js, and we're going to do that with the help option, something we haven't done anything to create. It actually comes by default with Yargs, and it displays some helpful information about what's going on with our little app. Now, this first part, this is still coming from our console.log on line 5, which we can go ahead and delete. It is the second part we're interested in. This is what's coming from Yargs itself. So it's printing a little cheat sheet about how to use our tool. It's showing two options that are available: help, which shows the help, that's what we're seeing right here, and -- version, which shows the version number of the tool we're using. That means we can actually run node app.js with that version option, and what do I get? I get 1.0.0. So by default, Yargs starts you off on that version, and you can always customize it to fit your needs. Let's go ahead and do that. Up above, I'll leave a little comment, customize Yargs version, and we do this by accessing Yargs and calling the version method. This takes to it a string as its one and only argument, and we provide our new version number. So maybe I'm ready to move on to 1.1.0 as an example. Now, if we were to save the program and to rerun that version command, what do we get? We get our new version number showing up. So Yargs comes with a ton of useful parsing and features on its own, but it can be configured to do pretty much anything you want, and that's what we're going to start to get into. Down below, I'm going to clear the output, and we're going to focus on setting up Yargs to work with the commands we need it to work with. For example, in the Notes application, people should be able to add notes, remove notes, read individual notes, and list out all their notes. These are 4 distinct commands we want to set up and customize. I want to display help options for each. I want options so I can pass in data, all sorts of things, and Yargs supports all of that. Let's start by working through one command together, the add command. So right here, create add command. And this starts by calling the command method on Yargs. That is yargs.command, and we pass to it an object. This is our options object where we can customize exactly how this command should work. Now, the first thing we have to provide is a name for the command. Is it add? Is it read? What is it? Right here, we do that by setting up a command property, setting its value equal to a string name. Now, I'm going to start with the add command, so I'll set up add as the value. From there, we can also add a description to describe exactly what this does. That happens via the describe property. This is also a string value, And I could have something like add a new note as a way to describe exactly what this command is supposed to do. Now, we can also set up a third property called handler. That's the code that's actually going to run when someone uses the add command. So down below, comma, the next property, handler. This needs to be set up with a function value, and that function gets executed if the command ever gets used. So right here, a brand new function. And for the moment, we're going to have a little placeholder console.log call, and we'll just say something like adding a new note. Excellent. Now let's go ahead and see how all of this is going to change our application by running it from the command line. To start, let's go ahead and use that help option. Right here, I'm going to run the file using the help option like we did previously, and we're going to notice that because we've registered a new command, we have a new commands section. In app.js, I have access to the add command, which adds a new note. Now let's go ahead and actually use it. So node app.js add, and when we run it, what do we get? We get our little message printing to the screen, adding a new note is showing up. So this proves that our handler is indeed running when someone runs our application trying to perform that add command, which is a fantastic step in the right direction. Now let's go ahead and add a second command into the mix. Down below, we're going to add a remove command. So create remove command. And once again, we are going to use yargs.command to set that up right here, passing in the options object, and we'll configure the same three properties. We need a command name. I'm going to call this one remove. We have to describe our command. Well, we actually don't have to describe it, but it is a good idea to describe it. I'll say something simple like remove a note. Then we're going to set up our handler function. So right here, setting that function up and providing some code to run when someone uses remove. Right here, console.log, removing the note. Perfect. Now we can use this second command from our program as well, and it's also going to get ended up listed in our help options. So I'll rerun the command I ran 2 commands ago to use the help option. Right here, I see remove showing up below add. Now let's use remove. Node app.js remove. And when I do, I can see that removing the note is printing, which is great. That is exactly what we were hoping for. Now it's going to be up to you to add 2 more commands for read and list. Let's go ahead and talk about what I'd like you to do. Right here, I'm going to paste in some challenge comments. There are 3 steps for getting this one done. The big picture goal, add 2 new commands, and you can do that right here below the remove command. Step 1, you're going to set up the list command, and for now, you can just print a placeholder message saying something like listing out all the notes. You want to use list as the name, and then you can pick a description that makes sense, something like list the notes. The other command you're going to create is the read command. Once again, you want to set up the command name, you want to give it a description, and for the moment, you're going to continue to print some sort of placeholder message until we actually wire up the functionality. Now, once you have both of those commands created using the command method, I want you to test your work by running both of them from the terminal and ensuring that you get the correct output. All right, take some time to knock that out. When you're done, come back and click play. How'd that go? Let's go ahead and kick things off by working with step 1. Right here, we are going to create that list command. So create list command. We're going to call yargs.command to register a brand new one, passing in our options object, and we'll start by setting up that command property. The name, list, then we'll set up a describe value, something like list your notes or anything similar would have worked. And last up, we have to set up a handler. So I will do just that, providing a function value. And once again, I mentioned you can just use a placeholder message for now. So console.log, something like listing out all notes. Perfect. Next up, step 2, we have to create the read command. So let's go ahead and do that as well. Create read command. with a call to yargs.command down below, passing in that same options object and setting up those same three properties. We're going to have our command property, the name for this one being read. I'm going to set up describe. And right here, we'll pick a description, read a note, and then finally, we're going to set up handler because we want to do something when someone runs that command. Right here, a placeholder, console.log, reading a note. Excellent. Now that we have that in place, it's time to move on to the most important step, step 3, which is to make sure that the code we wrote actually works as expected. And this is a very important part of every challenge. Let's go ahead and do just that down below. To start, I'll clear the terminal output, and we'll start with the list command. So node app.js list. Right here, listing out all notes shows up. I misspoke because I spelt things wrong. It should be listing out all notes. Excellent. Then we're going to go ahead and move on to the read command. So node app.js read. And what do I get? Reading a note shows up, which is great. And there we go. We now have a basic configuration with 4 commands set up to run code when the command is actually used. In the next video, we're going to wrap up our discussion of command line arguments by exploring how we can provide additional options for each of these commands. I'm excited to get to that, so let's go ahead and jump right in to the next one. In this video, we're going to wrap up our discussion of command line arguments by setting up Yargs to support some options for each of our commands. For example, the add command needs the title and body of the note you're adding. The remove command needs the title of the note you're trying to remove. And last up, our read command, it needs the title of the note you're trying to read. So we have to figure out how to configure options for those 3 commands. And the answer is that we set up another property on the configuration object we pass to command. This property, which I'm going to add right here after describe, is called builder. Builder's value is an object, and on that object, we can define all of the options we want this given command to support. Now, in the case of add, once again, there's 2, title and body. Let's start with title. To define a new option, we set it up as a property on the builder object. So if I want to be able to provide a title when I run the add command from the terminal, I can set up title right here in builder. Now the value for this property is an object, and in here we can customize how that option works. And the first thing we're going to do is set up the describe property, just like we did for our command up above. Describe for an option allows us to describe that option. And right here, I'm just going to say note title. Perfect. With our option defined, we can now access that in the command handler down below, and we get access to the arguments via this first argument that's provided to our function. So we give this function to Yargs, and when the command is executed, Yargs runs the function, and it calls it with argv, which contains all of those arguments. Let's go ahead and print that to the terminal so we can see what we get. Right here, after our string, I'm going to pass a second argument to console.log, and the second argument is just going to be the argv variable. Now we can save things and run our application from down below. What we're going to do is run node app.js add. We are going to provide that title option, and I'll set it equal to something like shopping list. I'm going to run the command, and what do I get? Right here, we have our console.log printing, adding a new note, followed by argv from inside of the handler. And right here, we have the title property with shopping list, which means we have access to argv.title, which we can now use to actually define a note. Now, one thing to point out is that these are not required, which means that I could run the command without title. Node app.js add. If I do that, what do I get? Things still seem to work even though no title was provided. Now it's up to us as the developers to decide whether or not a given option should be required. If it's not, you can leave the configuration as is. If you want it to be required, you can set that up as well. Right here, we have the demand option property. This is set to false by default. We can go ahead and flip that over to true, meaning that you have to provide it in order for the command to work correctly. Now let's try to run the script again without providing title, even though it's now required. When I do that, what do I get? I get an error message printing. It's saying we are missing required arguments and it lists them out. In this case, we are missing title. Right here, it even shows the available options for the add command, and we can see that we have title as the last one, and it is indeed shown as required over here on the right-hand side, which is correct. Now, the other thing we want to make sure is that we always get a string value for this particular option. So if you provide the option, but you don't give it a value, it's going to show up as a Boolean. Let's see what I mean by that. Node app.js add. Here we will use -- title, but I'm not going to set it equal to a string like we did previously. If I do this, we can see the value for title is true, which is not what we want. I want to make sure that the argv.title property is always a string. We can go ahead and enforce that by setting up another property on our little options object configuration. Right here, it is a type, and we're going to set the value equal to one of the supported types, which is string in lowercase. Now that we have this in place, we are always going to have a string value for title, and it's required, which means it's always going to be there. Now, it could be an empty string, but that's okay. We can always perform a little validation later on to make sure the title has content. But if I rerun that previous command, we can see that at least we have a string value for title instead of a Boolean, which is a great step in the right direction. And obviously, if I provided a string equals something like my title, that's going to show up right there, which is indeed ideal. So now we have this title option. We have a description for it. We've said that it needs to be provided, and we've said that we're always expecting a string, which is awesome. You'll notice in the terminal that we're getting the args printed twice because we print them once inside of the command handler for add, and then down below we print them again in a little console.log call. It's important to note that this is actually doing something. If we were to comment this line out and save the program, it wouldn't work as expected. If I rerun the exact same command, which worked a few moments ago, we can see we're not getting any output. So how exactly is printing the args making all of this work? Well, when we access the argv property on Yargs, Yargs knows to actually do its thing and parse those arguments. Now, if we don't need to access it, that can be less than ideal, so there's another way to get that done. It is yargs.parse. It doesn't take any arguments, and we can just call it like that. If we save the program and we rerun the command, now things are working once again, and we're seeing our arguments printed just a single time. So Yargs parse actually goes through the process of parsing the arguments with all of the configuration details you've provided with your Yargs command calls up above. It's almost challenge time, but before we get there, we are going to print the title explicitly down below as opposed to printing the entire object. So I'll remove our console.log and replace it with a new one. And I'm going to print two things. First up, I'm going to print a little title for the title. So I'll say something like title : space, and then I'll concatenate on the actual title value, which is on argv.title, where the title property matches up with the title property we chose to create up above. Now, if I run the script again, things are just a bit more organized right here. Title, my title is showing up. So now let's talk about what I'd like you to do as your challenge for the video. As always, I have some challenge comments right here describing what I'd like you to do. It is going to be your goal to add a new option to Yargs, and that's going to be for the add command. So right here, you're going to use what you've learned in the video to set up a body option for the add command, which means you'll be customizing the builder object we have right here, adding a second property. You're going to configure the body option to have a description. You can pick something that makes sense for you. You're going to make it a required option. We're going to need a body, and you're going to force it to be a string using the correct definition. Next up, you're going to log the body value in the handler function like we log the title down below. And finally, you're going to test your work. So you're going to run the command from the command line a few times. Try it once without providing the body and make sure that fails. Try it again while providing the body and make sure you see both your title and body printing. So all you need to do is edit this object, add some stuff inside of this function, and test things out from the command line. All right, take some time to knock that one out. As always, we're going to work through the solution together. So take a moment to pause the video, and when you're done, come back and click play. How'd that go? Let's kick things off together. We're going to be setting up a new body option, which means we need to add a new property onto the builder object. I could add it before or after title, either way works. I'm just going to add it right afterwards. Right here, the new property is called body. It is also going to have its value be an object like we did for title, and this is where we can customize it. So we want to set up a description, I want to make it required, and I want to make it a string. For the description, we use our handy describe property. I'll use a description of something like note body for this one. Then we're also going to require it by setting demand option equal to true. Remember, the default value is false. Finally, I'm going to set the type for this one equal to a string, so we always get a string value provided. So that's steps 1 and 2. Next up, you needed to log the value in the handler. So down here, we log out the title. I'm going to add a new console.log call to log out the body. So body : space. Then I'll concatenate on argv.body, where the body property comes from the same value as the name up above. Now that we have all of this in place, we can move on to the final step, which is to test our work and make sure we can now use body successfully. I'm going to save app.js. I am going to clear the terminal output just to give us a little bit of thinking space so it's not so cluttered, and we're going to use our new command. So node app.js, I am going to run add, and I'm going to do it with title. I'll provide a title. I'll just use a title like by, and I'm not going to provide a body, and that's intentional. When I do this, I'm expecting it to fail, and it does. Right here, missing a required argument body. I can see both title and body showing up, both required, which is fantastic. The next thing we're going to do is rerun the exact same command, but this time we are going to provide a body. So after a space, -- body equals, right here inside of double quotes, these are what I need to buy, period. Now, if we go ahead and run this command, what do we see? We see our two messages. I have the title console.log right here printing buy. That comes from line 33. And I have body. These are the things I need to buy coming from line 34. So there we go. That is it for the challenge. Our add command now takes in all of the options necessary for it to actually create a new note and save it to a data store. Figuring out how we're going to save our data, how we're going to save our notes is the topic of the very next video. So let's go ahead and jump right in to the next one. That's it for this 2-hour preview of the complete Node.js developer course. If you're interested in enrolling in the entire class, I'll include a link to the course landing page right here on the video and in the description down below. There you can check out the entire course curriculum and explore what else is covered in the class. I'm Andrew Mead from Mead.io, and I hope to see you in the full course sometime soon.